Hello, hi, namaskar everyone. Give me a quick response if I'm clearly visible and audible. Shall we get started, students? Can you all see me? Can you all hear me? I hope the screen is properly visible to everyone. Shall we get started? Give me a quick response. In the comments, do write if you all can hear me, if you all can see me, if the stream is properly visible to you all. Give me a quick response, everyone, so that we can straight away get started. So great. I think we are clearly visible and audible and we are getting started. Sir, what are we really starting today? Today, we are starting relations and functions. Sir, relations and functions is already covered in Arjuna. Why are we doing it? This is for all those students who have joined us late. So if you have joined us late in Arjuna batch, which is for class 11th JEE aspirants in English, and let's say you have missed this chapter. So here, through this video, you have the opportunity to cover the whole chapter. Although remember, it is a one shot. One shot means one shot. That means through this one chapter, through this one video, we'll cover this whole chapter. This whole chapter, this complete chapter through this one shot. So sir, what are you exactly saying? I am saying that all the concepts, all the theory, all the relevant apt appropriate examples with a decent amount of questions will do in this one shot for the chapter Relations and Functions for class 11th Arjuna JEE aspirants. This is your backlog series, so I welcome you all students. I hope most of you must have started watching it and we are getting started with this video. I hope you all can hear me, you all can see me. Great. Good evening everyone, good evening. Good to have you all. Good to have you all. And amazed by such good response. Thank you so much. Now let's get started with this. So sir, relations and functions, this is something we study in 12th standard. So in 11th, what is the difference? In 11th, you learn the basics. Sir, why to learn basics? Can we not learn the basics in 12th only? You learn those basics in 11th as well, because in 11th, you use a lot of functions. You use a lot of expressions. You use a lot of mathematical expressions where you deal with not only relations, but with functions. Good to have you, Arun Krishna from Kerala. Glad to hear that people from all over India, not just India, but worldwide people are watching us, giving us good response and appreciating our efforts. Thank you so much, Arun, for being here. Let's continue with our session. So I hope everybody is clearly watching and understanding whatever we are saying. So I am saying that relation and functions, the basics we'll be covering here. The basics which is needed, the basics which are needed to cover your 11th standard foundation. And then in 12th, we'll consolidate this chapter with more further concepts. So in the previous lecture, I hope you remember that we have covered sets. Very basic foundational chapter, sets. We can call it our first chapter for your JEE journey. And then now we are moving towards your second chapter, which is relations and functions. Now, sir, in this chapter, what exactly are we going to study? So before we study this chapter, I hope you do remember, we have covered sets in the last chapter. And I hope very basic definition, you know, that a collection, if you have a collection of objects, if you have, you will be able to create a set. So set has distinct elements. Set has distinct elements. So if you are fulfilling that condition, a collection if you are making, it is a set. And a lot of terminologies related to sets. I hope you remember subsets, proper subset, superset, universal set, cardinal numbers, you know, power set, and some formulates related on sets, De Morgan's law, and even we did a lot of Venn diagram based examples as well. So we, I think, covered sets thoroughly. If you have missed sets and if you are in Arjuna wanting to clear this backlog, you must watch sets as well. Great. We have some more students. Sir, I am in 12th. Can I see all the one shots by you? Only for JEE main? Definitely. Why should you not? And you do not ask, my friend. You can. You definitely can. But remember, this is 11th class one shot. And one shot, we all believe, are never sufficient for JEE main. Why do I say so? Let me be very honest and brutal here. For theoretical revision, one shots are good. But let's say you want a decent amount of practice, then you should practice those questions by yourself. Imagine this. Problem solving is a skill. So you cannot learn to solve a problem by seeing me solving the problem. It is same as, let's say you want to learn swimming. So you see me swimming, will you learn swimming? You see me cycling, will you learn cycling? You see me doing some or performing a skill, will you learn that? No. So to do that, to be able to do that, to become capable of that, you should do that by yourself. So one shots can help you in learning your concepts, but to learn them, to imbibe them, to incorporate them thoroughly, what you clearly need is more practice. And that practice is needed to be done by you alone. So I hope you understood my intent, my motive, the crystal clear clarity which I have tried giving you, that one shots theoretically will cover everything. But for more practice, you need to do questions by yourself. Everybody got my point? Even for JEE Mains and Advanced? Yes. Now, sets we have covered in the last session. Today we are starting with relations and functions. So let's straight away get started. Majorly, I'll begin my discussion with relations. So what are relations? I'll give you some clarity on relations. And then gradually, once we have understood relations, we'll understand its types, equivalence, symmetric, transitive, reflexive, and a lot more. And then gradually, we'll move towards functions. We'll talk about domain and all, and then we'll be done with this chapter. Yes, sir. So problems you are not able to solve and it is demotivating. I totally understand this. I totally understand this. So whenever you're stuck in a problem, give some decent amount of time to that problem. And after, once you have done decent amount of practice, then of course, look for the solution. Look at the solution, whether it is a text solution or a video solution, and understand which core area were you missing. Were you not able to look or think of the concept, or were you applying any silly mistake, or were you applying a wrong formula? And then maintain an error logbook. So in that error logbook, write those errors which you are committing. Let's say you are not able to apply a correct formula, write that here. Let's say you are missing a concept, write that there. Sir, why? Because that error logbook will behave as a Bible for you, Bible of your JEE preparation. So why? Because whenever you revise, you don't revise whole chapters. You don't revise all the PDFs. You don't revise all the questions. You just go through the error logbook. That will help you in understanding the mistakes which you are committing, the mistakes which you need to correct. And that's how you improve. I hope, Himanshi, I have answered your query correctly. So coming back to this discussion, everyone, I hope you heard me, everyone. Shall we move with our discussion? So first of all, let's talk about ordered pairs, everyone. So what is an ordered pair? For example, I write A comma B. I write 2 comma 3. I write 7 comma 8. I write 2.5 comma 3. That's an ordered pair. Simple. I hope it's direct, it's decent. So whenever we talk about ordered pairs, I hope you remember that in ordered pairs, you have two numbers written inside a bracket, small brackets we use, and we call them ordered pairs. Now there you need to learn this difference, students, that here, if you talk about ordered pairs as in A comma B and B comma A, then they are two different ordered pairs. A comma B and B comma A are not same. I hope you got my point, everybody. Now with this, you need to remember that if somebody says that, sir, this ordered pair A comma B is equal to C comma D, then if ordered pair A comma B is equal to C comma D, in that case, we need to remember that this A will be equal to C and this B will be equal to D. Did you all understand the concept of ordered pair, everybody? Any confusions? Yes or no? Now, sir, what is the Cartesian product of two sets? Let's say I'm given two sets. I'm given two sets, set A and set B, and I'm taking the Cartesian product. So, sir, what exactly is the meaning of Cartesian product? Let me help you with this statement and with this concept. Everybody, listen to me very carefully. Let's say there is a set A which has elements 1, 2. Sir, let's say there is a set B which has elements, let's say A, B, C. So these are two sets. Now, if I take the Cartesian product of these two sets, what happens in that case is, let's talk about that. So Cartesian product is given by A cross B. So A cross B is a Cartesian product from set A to set B. So what I'll do in Cartesian product is, I will map 1 with A, then 1 with B, then 1 with C. So 3 ordered pairs I'll get. Similarly, I'll map 2 with A, 2 with B, and 2 with C. So I hope you do realize that the ordered pairs which I'm going to get are going to be 1 comma A, then 1 comma B, then 1 comma C. Similarly, 2 comma A, 2 comma B, 2 comma C. So 3 more ordered pairs I'll get, 2 comma A, 2 comma B, and 2 comma C. So this is how you write the Cartesian product. Everybody got it, or shall I repeat it? What did I just do? I said that here, let's say if you have Cartesian product of A with B. So what do we do here with that? We simply take 1 comma A, 1 comma B, 1 comma C, 2 comma A, 2 comma B, and 2 comma C. So that's how you write the Cartesian product. Sir, here we noticed few more very interesting things. For example, number of elements in set A. If I ask you, how many are they? Sir, number of elements in set A are clearly 2. Sir, number of elements in set B, how many are they? Sir, number of elements in set B are clearly 3. So don't you notice that each of the elements from A will be mapped with each of the elements from B? Each of the elements from A will be mapped with each of the elements from B. So if I ask you, the Cartesian product of A and B will have how many elements? So sir, Cartesian product of A and B will have the number of elements in A into number of elements in B. Sir, why do you say this? Basic maths, students, basic maths. 1 can be mapped with these 3 elements, then 2 will be mapped with these 3 elements. So each of the elements of A will be mapped with each of the element of B, which means what? 2 elements from A will be mapped with 3 elements of B, which means total mappings I'll see are going to be 6. Everybody understood that? Just give me a quick thumbs up if you got my point. If you understood, how do we calculate number of elements in the Cartesian product of A and B? Everybody got this? Everybody understood this? Yes or no? All the participants. Do let me know if there is any confusion. I'll happily resolve it. Everybody. Did you all get this? All the participants. Shall I move ahead from here? If you all understood it, everybody give me a quick response. Now from here, one more thing you all need to understand is that this Cartesian product, the concept of ordered pairs, lays the foundation for a relation. Sir, what are you saying? We didn't get it. Okay, let me re-explain. I am saying, let's say here you want to define a relation. Let's say you want to define a relation. So out of this Cartesian product A cross B, out of this Cartesian product A cross B, if you choose any subset, great, good Gaurav, good unique soul. I am saying out of this Cartesian product A and B, let's say if I choose some elements, I pick some elements, I create a subset. So if I create a subset, sir, yes, I'm creating a subset. In that subset, I am choosing 1 comma B, 2 comma A, and 2 comma C. Okay, so this is a subset I have created. What did I just do? I am creating a subset of A cross B. And that set I am defining by, let's say, R1. So in that R1, I have chosen ordered pairs as 1 comma B. I have chosen ordered pair as 2 comma A, and I have chosen ordered pair as 2 comma C. So these 3 ordered pairs I have chosen. So listen to me very carefully, students. Any subset of A cross B is called a relation from A to B. Yes or no? Yes or no? Shall I repeat that? I am saying that here, let's say if you have a relation R1, which I have defined from set A to set B. So set A has some elements, set B has some elements. So from set A to set B, if I do the mapping, 1 is mapped with B, so 1 is mapped with B. Then we have 2, which is mapped with A, and then we have 2, which is mapped with C. So this is how this relations mapping look like. Everybody comfortably processed this idea. Everybody understood it. Yes or no, all the participants. Everybody got this result? Everybody give me a quick response. What am I asking here is a very crucial, a very important, a very significant result is that our relation is a subset of the Cartesian product of A with B. So whenever you see A cross B, and if you want to find a relation from A to B, then A cross B's any subset you choose will be called a relation from A to B. Did you all get this? Everybody understood how do we define relations? First of all, what did we do? In the last lecture, we discussed sets. From sets, now we have moved towards ordered pairs. From ordered pairs, we have gradually moved towards Cartesian product. And from Cartesian product, we are choosing any subset. And that subset is defined as a relation from A to B. Whoever was showering love or celebration or smileys to us, thank you so much. We really appreciate it. I hope all the other participants are also understanding the most important concept, relation. What is the relation, students? So if I could simply define a relation, so how will I define? Relation means what? Relation mathematically means what? Relation mathematically means that if I take A cross B, which means Cartesian product of A to B, then a relation from A to B is given by any subset of A cross B. Did you all get this definition? Did you all understand this definition? Now I have one more query. I have one more question. We know that, sir, in Cartesian product of A cross B, the total number of elements are NA into NB. As we have just discussed, do you remember that here we have discussed that number of elements in A cross B are number of elements in A, which are 2, number of elements in B, which are 3. So number of elements in A cross B are 6. Now let me ask you one more question. If you have watched the previous session sets, you would be able to answer it. The total number of subsets of A cross B would be how many? If you know this answer, do let me know in the comments. I'm waiting for your responses. What am I asking you? That set A has 2 elements, set B has 3 elements, A cross B has 3 into 2, 6 elements. What will be the total number of subsets of A cross B? Quickly tell me in the comments, everyone. All those who have gotten this answer, do let me know. What will be the answer, students? Come on, be quick. I hope most of you do remember it from the last session. If A has 2 elements, B has 3 elements, then A cross B will have, let's say, here in this case, 6 elements. So the total number of subsets, that's Shubham, brilliant, brilliant, brilliant. Total number of subsets, total number of subsets of A cross B, of the Cartesian A cross B, will be 2 to the power 6, and we know it is nothing but 64. Excellent, excellent. That's brilliant, Shubham. By the way, from here, I ask you one more question. What is that? Sir, 64 means what? Don't you think that from A to B, I can define 64 unique relations? Did you hear me? What did I just say? I said that A cross B, look at this scenario I'm talking about first of all. Everybody, please pay attention. In this scenario, A cross B has these 6 elements. So out of these 6 elements, I can choose nothing, or I can choose exactly 1 element, or I can choose exactly 2 elements, or I can choose exactly 3 elements, or I can choose exactly 4, or exactly 4, or exactly 6. So this is what you'll study in permutation and combination, that out of 6, exactly 0 can be chosen in 6C0 ways, or exactly 1 can be chosen in 6C1, or exactly 2 can be chosen in 6C2, or exactly 3 can be chosen in 6C3, or exactly 4 can be chosen in 6C4, exactly 5 can be chosen in 6C5, and all 6 can be chosen in 6C6 ways. This is what we'll study in permutation and combination. So remember that this result is nothing but 2 to the power 6. Always remember this result. NC0 plus NC1 plus NC2 plus NC3 plus NC4 until NCN is given as 2 to the power n. Let me give you one more approach. Let's say I have these 6 elements over here. So with each of these elements, how many choices do you have? So 1 comma A will say that I will either be a part of it or I won't be a part of it. Part of the subset. 1 comma B will say I will either be a part of that subset or I won't be a part of that subset. 1 comma C will also say I can be either a part of the subset or won't be a part of subset. So what are you realizing? Are you not realizing? Each of these elements have 2 choices. Either to be in the subset or not to be in the subset. So 2 choices and 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 2 choices. And means in the mathematics multiplication. So 2 into 2 into 2 into 2 into 2 into 2, 2 getting multiplied 6 times, that is 2 to the power 6. That is one another way of looking at it. Number of subsets. So did you all understand? if I have a set A, if I have a set B, so if I'm able to define total number of subsets of A cross B, don't you think it will be equal to total number of unique relations from A to B? Everybody got this statement, or shall I repeat it? All the participants, do let me know in the comment box if you are feeling confused. Did you all get this? All the participants. Shall I continue further from here? Did you all understand the terminology of relations? Give me a quick response if there is any confusion. Give me a quick response if there is any confusion. So what did I just say? Sir, a relation is merely nothing. But if you take Cartesian product of two sets, and if you choose any subset out of that Cartesian product, that's a relation. Everybody with me so far? Sir, how many number of relations, I mean unique relations which you can form from A to B? That will be the total number of subsets. So if A cross B has n elements, the total number of subsets of A cross B will be 2 to the power n. So from A to B, I can create 2 to the power n unique relations. Did you all get this? Alpha is asking this from the last session. Indeed, Alpha. That relation will be called an empty relation. Let me clarify this for you. You are always asking us good doubts. That's good. Keep it up, Alpha. I really appreciate your spirit. So Alpha is saying that, sir, there is set A, there is set B. There is a set A and there is set B. And from set A has few elements like 1, 2. Set B has elements like A, B and C. But I don't map anything with anyone. Is it also a set or a relation? Of course, it's a relation. So let's say I name this relation as R2, and in this relation, there are no ordered pairs. So no ordered pairs, yes. Nothing is mapped with nothing. It's phi, it's null, it's void, it's empty. So such relation where it is mapped with nothing, I mean nothing is mapped with nothing, is called an empty relation. So when you talk about that number of relations, and A cross B, which was 2 to the power 6, which was 64. So among those 64 relations, one relation was this relation, which was an empty relation. Did I clarify your doubt, my friend Alpha, or are you still feeling confused? So I hope you're getting some clarity on this thing, null, void, empty, which was confusing you a little in the last class, right? Everybody got this? Any confusions? Shall I move ahead from here, all the participants? Everybody with me, any queries or concerns if you have, please ask. Now, I want you all to understand the concept of domain in range from the perspective of a relation. Okay, sir, let's go through it. So let's say I'm given a relation. And in that relation, I am told that A cross B is looking like this. So A has elements 1, 2 and 3. B has elements 3, 5 and 7. So quickly tell me what will be the Cartesian product here, students. Sir, Cartesian product you're asking, right? Yes. So Cartesian product means 1, 3, 1, 5, 1, 7, 3 elements. Then 2, 3, 2, 5, 2, 7, 3 more elements. Then 3, 3, 3, 5 and 3, 7 to total 9 elements. So A cross B will have total 9 elements. So if somebody asks you, let's say if somebody asks you total number of relations from A to B, what will be your answer, students? Sir, total number of subsets of A cross B. So sir, how many elements are there in A cross B? Sir, elements in A cross B are elements in A into elements in B. So A has 3 elements, B has 3 elements. So A cross B will have 3 into 3, 9 elements. I hope you can see these 9 elements. So I'll say total number of relations from A to B will be total number of subsets of A cross B. So A cross B has 9 elements. So total number of subsets of A cross B will be 2 to the power 9, which is 512 unique relations I can define. Can you believe this? 512 unique relations you can define out of these 9 ordered pairs only. Can you believe that? Beauty of mathematics. Are you realizing it? Sir, okay, we get it. But sir, you were explaining domain in range, right? Yes, I was explaining domain in range. So what exactly do you mean by domain in range? By domain in range, I wish to say that here let's say if I have chosen any subset in which I have chosen 1 comma 5, I have chosen 1 comma 7, I have chosen 3 comma 5 and 3 comma 7. So if I make you look, if I make you look at one of the mappings which we are creating here, so please pay attention everyone. Let's say here we have this set A, we have this set B, and I'm mapping set A with set B under this relation R. So there is this relation R. Hold on for a while, students. I'll just grab it here. Hope it looks sorted. So here you have a relation R. So in this relation R, what are we seeing? Sir, we are seeing 1 comma 5. So 1 is mapped with 5. Sir, we are seeing 1 comma 7. So 1 is mapped with 7. Sir, we are seeing 3 comma 5. So 3 is mapped with 5. Sir, we are seeing 3 comma 7. So 3 is mapped with 7. So what has just happened, students? Sir, when you look at the elements here, which are mapped with the elements here, that's very good, Alpha. That's very good. Excellent, excellent, excellent. So here I had two elements 1 and 3. So these elements are going to be the domain of this relation R. Here I had two elements 5 and 7. So these elements are going to be the range of this relation R. Everybody processed this idea comfortably, or are you feeling confused? Do let me know if there is any doubt. I'll clarify. Everybody got this, yes or no? So what did I just say? I said these elements 1, 3 will be the domain. And these elements 5, 7 will be here the range. Everybody comfortably got it. Everybody comfortably understood the concept of domain and range for a relation. Yes or no, all the participants? Yes, let me know, Dhruv, what's wrong or incorrect here. Do let me know. I'll clarify. Don't worry. I will. Don't worry, Dhruv. Let us know where are we wrong. I'll definitely correct it. Don't worry. So, as we were asked that 2 to the power n contains one of those relations as well, which is void relation, which is an empty relation. So, what is an empty relation here, students? Sir, empty relation means that here you don't have any mapping done, which means R is absolutely phi. It is called an empty relation. Everybody got this, yes or no? Similarly, there exists a universal relation as well. Universal relationship means empty had nothing. So universal will have everything. What did I just say? I said that let's say here A is 1 comma 2. So if I take the Cartesian product of A with A, so imagine there is a set A which is 1 comma 2. So what will be the Cartesian product of A with A? Cartesian product of A with A will be 1 will be mapped with 1, 1 will be mapped with 2, then 2 will be mapped with 1, and then 2 will be mapped with 2. Yes or no? Everybody getting it? Yes or no? Everybody getting it comfortably, all the participants. So this is mapping of A with A, Cartesian product of A with A. So when I take Cartesian product of A with A, I get these 4 elements. Why? Because A had 2 elements, 2 into 2, 4. So empty relation had nothing. Universal relation will have everything. So if I now define a relation, which contains all of these elements 1 comma 1, 1 comma 2, 2 comma 1 and 2 comma 2. So if it contains all of the elements, it is called a universal relation on A. Listen to my language very carefully. It is called a relation which is a universal relation but on A. On A. My friend Unique Soul, we have done something really important and significant and amazing for you. The channel at which you are watching this video right now, PWJ English, just go to the video section of ours. There you will find a video titled as How to Clear 6 Months Backlog. Sorry, How to Clear Backlog in 6 Months. It is titled as How to Clear Backlog in 6 Months, but in that video, I have covered a detailed strategy to come out of that demotivation which you're going through, where you're thinking of taking a drop. I have given you a kind of hope that you can still struggle, strive, and definitely get something decent out of where you stand today. Trust me, my friend, unique soul. Absolutely, that's exactly the point which I have addressed today. That's exactly the point which I have addressed today. So just go through our video section. There you'll find a video titled as how to cover your backlog in these last 6 months. So it is not merely a video on covering the backlog, but it covers a complete strategy, a guide that how can you still get something really good out of here. Trust me, just go and watch it. You will get something really decent out of it. Perfect. Brilliant, my friend. So I hope you all understood the concept of universal relation. Everybody, yes or no? Now, after universal relation, let's talk about inverse relation. So what is an inverse relation? So there is a relation. If I swap domain by range, it will become an inverse relation. Sir, what did you just say? I'll explain it with an example. Let's say here there is a relation R. Here there is a relation R which has 3 elements. Sir, which 3 elements? 1, 2, 3, 4 and 5, 6. So R inverse, first of all, don't call it reciprocal of R. No, it is not 1 upon R. -1 here in the index means this is a symbol representing that this is R inverse, inverse of a relation. So when you look for inverse of a relation, range becomes domain, domain becomes range. But the mapping still remains same, which means 1 is mapped with 2, 2 will be mapped with 1, 3 was mapped with 4, 4 will be mapped with 3, 5 was mapped with 6, 6 will be mapped with 5. So the mapping still remains same. Everybody got it? Yes or no? All the participants, do let me know if there is any confusion. I'd love to clarify. Everybody got this? All the participants? Yes or no? Any queries or confusions if you have, please ask. I'll clarify. Yes or no? Did you all get R inverse? Did you all understand the concept of inverse of a relation? Now let's discuss something really amazing, which is called reflexive relation. Let us now discuss something really interesting and important, which is called reflexive relation. What is a reflexive relation, sir? Let us say I have a set A 1, 2, 3. So I define a relation on A, which means A cross A. I repeat, whenever I say a relation on A, so it means I am talking about A cross A and I'm taking its subset. So I'm defining a relation R1, which is a relation on A. So I'm taking a subset from A cross A. Absolutely, Alpha. Beautiful, interesting. That's very good. So, sir, when you're defining a relation on A cross A, I mean, you're taking a subset from there. And if you ever see, all the elements of set A are mapped with the elements of A. I mean, the identity relations extension you see here. What did you just say, sir? I am saying that let's say A has these 3 elements, 1, 2, 3. A has these 3 elements, 1, 2, and 3. So, sir, elements of A, 1, 2, 3, are if mapped with themselves, which means 1 is mapped with 1, 2 is mapped with 2, and 3 is mapped with 3. All the elements of A should be mapped with themselves. If you see such relation, if you see such mapping, you would call it a reflexive relation. Shall I repeat that? Let's check it with some examples. Let's say there is a set A which contains these 3 elements 1, 2, 3, and there I want to verify that this relation R1, R2, R3 are reflexive or not. So how do we do that? Let's talk about that. Everybody, please pay attention. R1 is 1, 1, 2, 2, 3, 3. So are all the elements of A mapped with themselves? Yes. So R1 is our reflexive relation. Everybody got this comfortably, or shall I repeat it? Okay, sir, let's talk about R2. You tell me in the comments, is R2 a reflexive relation? Let me know, what do you think of R2 and R3? Are they reflexive relation? And if you think they are, why? If you think they are not a reflexive relation, why not? Do let me know. So here, R2 is a relation where 1 is mapped with 1, where 2 is mapped with 2, where 3 is mapped with 3. But sir, I see some more mappings. That's perfectly fine. 1 is mapped with 2, 2 is mapped with 1, 1 is mapped with 3. These mappings are absolutely fine. No problems with that. But do you see the mappings that for the elements of A, 1, 1, 2, 2, 3, 3 exist? Yes, sir, at least these 3 mappings exist. Apart from that, there are some more mappings. It is perfectly fine. It is perfectly okay. What you should have been noticing here is that 1, 1, 2, 2, 3, 3 must have existed. Yes, sir, they are existing. So if 1, 1, 2, 2 and 3, 3 exist, whatever apart from that there exist will still remain, or I'll call it a reflexive relation. What did I just say? I am saying that whatever are the elements in A, all those elements should be mapped with themselves. So 1 should be mapped with 1, 2 should be mapped with 2, 3 should be mapped with 3. Apart from that, any other mapping I see, I'll be happy. I'll be really happy. But at least these 3 mappings, 1, 1, 2, 2, 3, 3, I must see. Did I answer your query statements? Everybody, tell me yes or no. So I hope R2 is definitely again a reflexive relation. But can you help me with R3 students? What do you think? Is R3 a reflexive relation? Let's check it out. Sir, R3 has 1, 1, great. R3 has 2, 2, great. R3 does not have 3, 3. So, sir, what was the definition of a reflexive relation? A reflexive relation simply means that, sir, 1, 1, 2, 2, 3, 3 must have been there. Apart from that, whatever is there, I'm fine. But at least these 3 elements should be there. Which means what? Which means R3 is clearly not a reflexive relation. Some of you do get confused with reflexive and identity relation. First of all, understand what is an identity relation. This R1 is here an identity relation on set A. If you could be more specific, my friend Pankit, I may try to help you. But when you just say that periodic test you're having, you're stressed, what else? I mean, how can I help you with? Can you be more specific? Can you elaborate your concern a little so that I can address it in a more specific manner? So here what I'm saying is, please pay attention everyone, that if A has 3 elements, 1, 2, 3. So 1 is mapped with 1, 2 is mapped with 2 and 3 is mapped with 3. That's it. That's it. Nothing else more than this, nothing else less than this if I'm given. Then such relation will be called an identity relation on that set. For example, A here in this case. Did I answer your query or shall I repeat it? So have you all understood 2 types of relations? I think I have told you what is an identity relation and I have told you a reflexive relation. Everybody got this? Can we move ahead from here, all the participants, if you all have understood it? Now there comes a concept of symmetric relation. Sir, what is a symmetric relation? Can somebody in the comments tell me what is a symmetric relation? Anyone? Sir, if A leads you to B, then B should lead you towards A. What did I just say? I am saying here a very simple and a direct result, students, that if you have a relation R1 where 1 is taking you towards 2. So 2 should take you towards 1. So if any 1, 2 exist, and for that if 2, 1 also exist, then I'll call this relation to be a symmetric relation. Absolutely alpha. If A are B, then B are A. Perfect definition. Perfect. For all A which are there in set capital A. I hope this is a condition which you should not miss at all. Yes or no? Sir, what about this relation R2? Will you call this relation R2 also a symmetric relation? Is it also a symmetric relation? Let's verify it. So, sir, R2 has a pair 1, 2. So, sir, for 1, 2, do we see a 2, 1? Yes, we do see it. Sir, for 1, 3, do we see 3, 1? Yes, we do see it. So, if A, B and B, A both are there, this relation will again be called a symmetric relation. Absolutely alpha. Absolutely. Absolutely. The third relation, for example, I'm taking is R3. So do you see the problem with R3? Sir, what problem? I hope you do see that for 1 comma 3, 3 comma 1 is there, but for 2 comma 3, where is 3 comma 2? Do we see any 3 comma 2? No, which means R3 is clearly not a symmetric relation. Did you all get this? So what I'll say is R1 was symmetric, R2 was symmetric, but R3 was not a symmetric relation. Everybody got this? Any confusions if you have, please ask. Any doubts if you have, please ask. Everybody, yes or no? Now let's talk about the next type of relationship, which is transitive relation. The next type of relation, which is called a transitive relation. So what is a transitive relation? What is a transitive relation, students? So transitive relation, if you look at, then here definition follows two levels. If A takes you towards B, if B takes you towards C, then A should be able to take you towards C. Sir, is it not very complicating? I hope you got it. If still you didn't get it, I'll explain here. Look at this. There was this set A which had three elements 1, 2, 3. Now I am defining a relation R1 on this set A. What am I doing here in this case is, let's talk about that. Please pay attention everyone. I clearly see that there are three elements 1, 2, 3. 1, 2, 3. So now let's simply look at R1. Let's simply look at R1. Everybody, please pay attention. So in R1, what I see is, sir, 1 is taking you towards 2. So sir, give me a second, everyone. 1 is taking you towards 2. So I'm writing an arrow like this. 2 is taking you towards 3. So 2 is taking you towards 3. Sir, 1 is taking you towards 3. So yes, that's exactly what is needed. Sir, 3 is taking you towards 2. 3 is taking you towards 2. Now look at this, everyone. Look at this, everyone. That's good, Alpha. Excellent. I hope some of you may have noticed, some of you may have not. Let me clarify this once again. 1 is taking you towards 2. 2 is taking you towards 3. So there should be a pair where 1 is taking you towards 3 because this 2 and this 2 is common between them. Did you all get this? 1 is leading me towards 2. 2 is leading me towards 3. So 1 should lead me towards 3. I have that. Perfect. Brilliant. It got fulfilled. Okay, sir. Okay, sir. Okay, sir. What else? Other than that, what else do we have? Let's talk about that as well. So here, 1 is taking me towards 3. 1 is taking me towards 3. 3 is taking me towards 2. So the common entity was 3. So I should have 1 taking me towards 2. So do I have 1 taking me towards 2? Yes. I have 1 taking me towards 2. But sir, one link is missing there. One problem is there. Sir, what problem? What problem? Yes. The problem is 3 is taking us towards 2. 3 is taking us towards 2. 2 is taking us towards 3. 2 is taking us towards 3. So 3 should have taken us towards 3. 3 should have taken us towards 3, which means 3, 3 should have been there. Getting my point, everyone? Are you understanding what are we missing here? Are you understanding what are we missing here? Yes or no? Yes or no? Yes or no? Shall I repeat that? What did I just say? I am saying 1 took us towards 2. 2 took us towards 3. So 1 should have been able to take us towards 3. Perfectly fine, sir. That is following the definition. Great. Excellent. Then what next? Then 1 took us towards 3. 1 took us towards 3. 3 took us towards 2. So sir, 1 should have been able to take us towards 2. Okay, that is also happening. Perfectly fine. That's great, sir. That's excellent. No problems with that. But is there any other problem we are seeing? Yes. What problem? Let me talk about that. Here, I repeat that here 3 is taking you towards 2. 2 is taking you towards 3. So 3 should have been able to take you towards 3. Sir, what did you just say? We did not process it. Okay, let me reiterate it. 3 is taking you towards 2. 2 is taking you towards 3. So 3 should have been able to take you towards 3. I don't have 3, 3. Let me re-explain. 2 is taking me towards 3. 3 is taking me towards 2. So 2 should be able to take me towards 2, which is not there in this relation. So 2, 2, 3, 3 should also have been here and they are missing. So if they are missing, this is not a transitive relation. Shall I repeat that? Did you all get the reason that why are we calling that R1 is not a transitive relation? Sir, it was true for some cases, but is it true for all the cases? No. So it should be true for all the cases. For any A comma B and B comma C, there should exist A comma C. If for any A comma B, B comma C, A comma C is missing, I'll say it is not transitive. I'll just look for one reason to deny it, to reject it. Getting my point, everyone? Getting it, yes or no? Or shall I repeat it? Did you all get this R1? Shall I explain it with R2? Let's quickly understand it with R2 so that you get more clarity on it. R2 has 2, 3. R2 has 3, 1. So I hope you do see the problem here again. We'll talk about that alpha very soon. Let me just get in transitive. Then we'll talk about equivalence relations as well. Don't worry. So 2 is taking you towards 3. 3 is taking you towards 1, which means what? I hope you do remember. We have 2, 3. We have 3, 1. So I hope you do religion. 2, 3, 3, 1. So should we not have 2, 1 to call it a transitive? Yes. Do I have a 2, 1? No. Which means R1, R2, none of them are transitive. Okay, sir. What about R3? Can we have R3 to be a transitive relation? Let's check it out. Let's check R3. So R3 here says 1, 3. So 1 is taking you towards 3. 3, 2. So 3 is taking you towards 2. 1, 2. So I think, sir, I don't see any other reason to neglect it or to ignore it or to reject it that it is not a relation, transitive relation. Good to have you, Ritik. Good to have you. Glad to have you. Excellent. But I think you are having a class going on. Why are you here on this YouTube live? Why are you not attending the class? I think you're supposed to attend your class. This is what you do when even I take the classes. You just keep shuffling between YouTube and the application. Ritik, come on, answer this quickly. I think you have a class going on right now. There's already a class going on right now. How have you arrived here on this YouTube channel right now? So what did I say? Sir, we have 1, 3. We have 3, 2. So as per the transitive relations definition, 1 is taking me towards 3. 3 is taking me towards 3. 3 is that common link. So I should have 1 is taking me towards 2, which indeed I do have. Yes or no? So this relation is indeed a transitive relation. Everybody got it. Everybody understood it. Any confusion? So did you all understand all the 3 definitions? All the 3 definitions, did you all get it? Did you all understand 3 definitions I have given you? Reflexive, symmetric, and transitive. Did you all understand all 3? Everybody, give me a quick response. Now, JEE Mains has given a question in 2024 on this, which we'll understand with a poll. So let's see what does it say. Everybody, do give it a try along with me. You can simultaneously keep solving it. So it says, R is a relation on Z cross Z. What is Z? Z is the set of integers. So I hope you understand that Z is a set of integers. So imagine this in your brain, all the integers and all the integers, you take the cross product, you take the Cartesian product, and with that Cartesian product, you choose a subset out of it. And that's a relation, right? Now this relation follows the definition that it will not have an ordered pair, but actually an ordered pair will be mapped with an ordered pair. I am sorry. Okay, Ritik, now go back to your class, watch it with utmost sincerity, and come back here once you're done with your classes, right? Right now, there is already a class going on. This session you want to watch, we totally appreciate it, but this session you should watch after your live classes are over on the application. All the Arjuna batch students, come on. Vijay, good to have you. Good to have you. So this question here says that A comma B and C comma D, A comma B is mapped with C comma D, where AD minus BC is divisible by 5. Where AD minus BC is divisible by 5. Then they are asking you that R is reflexive, symmetric, transitive or not. What kind of relation it is. So I hope everybody must have read the question. Shall we give this question a try, all the participants? So how do we really do it, sir? Let me first of all try and define this question one more time for you all. It says that A comma B is mapped with C comma D. It will be called a pair in the relation R if AD minus BC, is divisible by 5. If it is divisible by 5. I hope you heard me right, everybody. Now, how do I check whether it is reflexive, symmetric, and transitive or not? Okay, let's go ahead one by one. So I'll check it whether it is reflexive, symmetric, and transitive or not. So first of all, let's check whether it is reflexive or not. So reflexive would mean what? So reflexive would mean that if there is a pair A comma B, so this pair A comma B should be mapped with the same pair A comma B. If A comma A exists, then we call such relation to be a reflexive relation. But here, a pair is mapped with a pair. So this is not a relation where an element is mapped with an element, but actually an element is a pair. So a pair is mapped with a pair, and that's how elements are mapped. So this relation is defined as A comma B mapped with C comma D, where I need to check whether it is reflexive or not. So how will I check it? I will say that, sir, if A comma B is mapped with A comma B, I'll call it reflexive. So the definition says that it will be mapped with itself if AD minus BC is divisible by 5. So A is A, D is coming here, B is coming here, and C is coming from here. So A, D, I hope you understood me, minus B, C. I hope you can see that C is A actually. A, D, B, C. So AB minus BA, what is that? Sir, that is 0. So is 0 divisible by 5? Sir, always. Always. Yes or no? For example, if I give you an example, I take 2 comma 3 with a 2 comma 3. Do I see 2 comma 3 mapped with itself? Let's check it out. How? I will say A comma D. Sorry, A into D. So that's A, that's D. So 2 into 3, 6. Minus B comma C. This is B, this is C. So 3 into 6. So 6 minus 6 is always 0, which is divisible by 5. Always, always, always. So I'll say, sir, first of all, it is reflexive. So whichever option says it is reflexive will be my correct answer. Whichever option says it is not reflexive will not be. And unfortunately, all the options have reflexive. So first of all, I should have read all the options. If I were to solve this question in IIT JEE, I would not check it whether it is reflexive or not, because all the options are telling me it is reflexive. So what is the point of checking whether it is reflexive or not? They have already told us that it is reflexive. So now the only difference will be, sir, symmetric and transitive. If you could decide, your job will be done. Yes. Most of you may have already realized by now that, sir, it will be symmetric. Why? Because if somebody says that here A comma B will maps with C comma D, so to call it symmetric, C comma D should be mapped with A comma B. So here I'll say that A comma B maps with C comma D if A, D minus B, C is divisible by 5. So in this case, this is A, this is D, minus, I hope you're listening and understanding, B, C. Are you listening and understanding? Are you listening and understanding? I'm just saying something and doing something. I repeat, A, D. So this is AD. And this is BC. Yes or no? 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 Everybody. So don't you think that, sir, if AD minus BC is divisible by 5, if AD minus BC is divisible by 5, then CB minus AD, if I take minus sign common, I'll be left with AD minus BC. Sir, this will also be divisible by 5. If this was giving me a quotient 4, it will give me a quotient minus 4. Did you get my language? I hope I'm not confusing anyone. What did I just do? I said a very simple thing that, let's say 2 comma 3 maps with, let's say I will take some example. What is AD minus BC, right? So A, then I'm choosing something from here, then minus B, C, right? So let's take it as 5, let's take it as 10. So now, what is it? A, D. Yes or no? minus BC. So is that divisible by 5? 20, 15, that's 5. So 5 is divisible by 5, yes or no? So that's true. So sir, if A comma B is mapped with C comma D, do you see C comma D mapped with A comma B? Let's check it. So 5 comma 10 should be mapped with 2 comma 3. So what will be ADBC in this case? AD, so 5 into 3, 15. What is BC? 10, 2, that's 20, which is minus 5, and minus 5 is also divisible by 5. So I hope you do realize and accept, if AB is mapped with CD, then CD will also be mapped with AB, so it is indeed symmetric. So whichever option says it is not symmetric will be incorrect. Whichever option says it is not symmetric will be incorrect. So now I need to check whether it is transitive or not. Now you let me know whether it is transitive or not in the comments. I am hoping for your responses. If you have understood this question so far with the utmost clarity, let me know very quickly, or I give you this part as a homework that you figure it out whether this is transitive or not. So 2 parts I have done, reflexive and symmetric. The next part, whether it is transitive or not, I am giving you as an assignment. But yes, when I give you this as an homework, I'll definitely give you the hint, don't worry. I'll definitely give you the hint, don't worry. For transitive, I'll say that if there exists A comma B leading towards C comma D, there exists C comma D leading towards E comma F. So there should exist A comma B leading towards E comma F. And I think that's a little less improbable. So when you check it for transitive, don't try to prove it is transitive. Rather try to prove that it is not transitive. Look for cases, look for examples. And if you could bring out some cases, some examples through which you can say it is not transitive, then one example is sufficient to say it is not transitive. Vijay, in some cases you may find it to be transitive, but try to look for those cases where you can create that it could not be transitive. For example, let's say, let me just take some numbers. I'll just try to do it. For example, let's say A is 5, A is 2, B is 3, C is 5, D is 10. So I hope what we are checking is AD minus BC. So what will be AD? 2 into 10, that's 20. What is BC? 3 into 5, that is 15. So sir, this is 5 divisible by 5. This is an acceptable pair. Okay, great. Now let's check it for 5 comma 10 with, let's say 4 comma 7. So sir, here I hope you do get it. AD, so 5 into 7, that is 35. BC, 10 into 4, that is 40. 35, 40, the difference is minus 5. So this is also divisible by 5. So this is also an acceptable pair, yes or no? Now let's check it for AB to EF. So this is AB, which is 2 comma 3. This is EF, which is 4 comma 7. So what does it say? Sir, it says this, I hope you're listening, 2 into 7, that is 14. 4 into 3, that's 12, and 14 minus 12 is 2, which is not divisible by 5. So Vijay, did you correct yourself now? This looked like transitive, but it is not necessarily transitive. I just tried proving it wrong. Instead of trying to prove transitive, look for the cases through which you can prove that it is not transitive. If you could create it, if you could see it, you would say it is not. And I'll say that, sir, this question I was trying to give you as a homework question. Unfortunately, I've done it. Don't worry. So, sir, wherever it says transitive, it will be wrong. It should be reflexive and symmetric, but not transitive. Option A. I'm sure some of you may have gotten option A correctly. Anyone? No one? No worries. But I'm sure very soon you would be able to. Yes or no? Now comes the most interesting part, which is said to be a reflexive relation. Sir, what is a reflexive relation? Option 1 was correct. Yes, Vijay. So a reflexive relation here would mean that, sir, if a relation is equivalence relation, I'm saying. So an equivalence relation would mean if a relation is reflexive, symmetric, and transitive, we call such relation to be an equivalence relation. And equivalence relation is denoted by this wiggle sign. So whenever you see a relation which is reflexive, symmetric, transitive, we call such relation to be an equivalence relation. Sir, what do you mean by that? Can you explain that? Yes, I can. Why would I not? So here, let's take an example to understand whether this relation is an equivalence relation or not. Okay. So I'll begin this question. Again, this has some options and I would really appreciate if you could participate in this poll and let me know which option do you think is correct. So by the time I'm having some water, you try it and let me know which option do you think could be correct here in this question. Everybody give it a try. Okay, everybody. Anyone who's able to do it? Anyone who has done this question? The question here is a pretty simple one. Trust me, the language is really simple. There is a relation R, which is the ordered pair x and y, where both are integers, and x plus y is an even. Absolutely, Alpha. Absolutely. This is exactly what I tell them. Specifically for transitive. Transitive is, of course, little confusing sometimes, rather most of the times. So instead of trying to prove it is transitive, for which you will or you may get some sufficient cases, you should try to prove that it is not transitive. And if one case you are able to find, you should claim it is not. Simple. So here we are trying to check it whether it is reflexive, symmetric and transitive or not. So reflexive. If x comma x exist, then I'll call it reflexive. So sir, x and x both are integers and then x plus x should be even. Sir, x plus x is 2x. Now whatever x is, 2 into any integer will be what? An even number. So what have we just proved? That sir, without any hesitation, it will be a reflexive. Imagine this, you put a 3 comma 3. So 3 comma 3, sir, 3 plus 3, 6, even. Odd plus odd, even plus even will be even. So sir, first of all, this is definitely reflexive. This is definitely reflexive. So whichever option says it is not reflexive will be wrong. Yes or no? Yes or no? Now let's check whether it is symmetric or not. Everybody got this? Yes or no? All the participants. So sir, you want to check whether it is symmetric or not? Yes. So to check whether it is symmetric, I'll say if x comma y is there, y comma x should also be there. Yes or no? So come on, sir, come on. If x plus y is even, then don't you think y plus x will also be even? Yes, 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 yes. That's true. That's true. Which means if x comma y is there in that set, y comma x will also be there in that set or relation. For example, let's say if I say 5 comma 7 is there, so 5 plus 7 is 12, it will be there. So of course 7 comma 5 will also be there because 7 comma 5 is still that same 12, which is even. Getting my point? So will I not say, sir, it is reflexive as well as symmetric? So if our option says that it is not symmetric, it could be wrong. So I'm now left with option A and B, which means now I need to decide which option is correct, whether it is transitive or equivalence. So again, don't be in a rush, Vijay, don't be in a rush. So let us again try to prove. Let us try to prove that here it is not transitive. Alpha, if you are not able to see the whole board in your mobile phone, try to zoom it out. Just with your 2 fingers, try to do that. I think you'll be able to achieve that. So I come back to this conclusion. Now let's check whether it is transitive or not. So what do you mean by transitive? So transitive, here I am trying to say that, let's say if I have 3 comma 5. Listen to me very carefully. Both are odd. Or let's say I have 4 comma 6. Both are even. So if both are odd, then only sum will be even. Or if both are even, then only sum will be even. Are you listening and understanding whatever I'm saying? I am saying an odd number plus an odd. This is not 5, this is odd. I'll write it more specifically. An odd plus odd is even, or we know an even plus even is even. I'm trying to give you the hint through which you can solve this question, through which you can check whether it is transitive or not. So pay attention and get some clarity, build on this data. That, sir, if I know this basic concept that odd plus odd is even, or even plus even is even, then what are you trying to say here is a simple fact that if I see pairs like this, for example, 3, 5 and 5, 7, then of course I will see 3, 7 as well, because 3 plus 5 odd plus odd, 5 plus 7 odd plus odd, 3 plus 7 odd plus odd. So if A comma B, B comma C is there, A comma C will definitely be there. If both of them are odd, it is true. Same is true for even as well. Let's say if 2 comma 4 is there, if 4 comma 12 is there, then don't you think 2 comma 12 will be there? Even, 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 even. Are you understanding my language, everyone? Are you processing this? So don't you think it is transitive as well? So if an option says it is not transitive, it is false, the correct option will be it is an equivalence relation. So option B should have been marked by most of you. Let's check whether it is correct or not. That's good, Vijay. That's excellent. Option B. Perfect. Brilliant. Vijay ensured that this time he doesn't miss the poll. So he kept on writing B, 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 B infinitely many times. Good. Keep it up. So with this, let us move towards the next part. Let us move towards the next part where we will talk about functions. So I'll start discussing functions after a break. Let's take 10 to 15 minutes break. You also get settled, have a break, hydrate, walk around, stretch, eat something, and then we'll start after 15 minutes. So just quick break and then we'll resume, everyone. I didn't get your query, Vishal. What were you saying? Can you repeat your concern or question? I'll re-explain, don't worry. By the way, I have always been mentioning this idea that whenever you look at one-shots as a resource to revise the whole chapter, theoretically it is a good idea, but I hope you do remember that in our batches also we push this idea that practice is what makes you more complete towards IIT JEE. Technically speaking, you're never complete, you just approach towards completion or betterment. But I hope you do realize practice you can do with a lot of questions. And in our Arjuna batch with Infinity Plan, there is a feature which is infinite practice. So what is that? Can you believe this? Infinite practice means you can create your own test customized as per your needs. For example, in relations and functions, you think you are good at, you want better practice. So you can ask a test of certain number of questions to be created based on the kind of difficulty level you want in that paper. You can create tests as per your needs. Let's say you find complex numbers to be a really tough chapter. There you think that's a moderate questions I want to practice. You can get a test created. That's the beauty of infinite practice. Coming back to the discussion we are having here, please pay attention everyone. That let's say there is a machine. Let's say, sir, there is a machine. So to this machine, let's say if I'm passing some inputs and if this machine is producing some outputs, let's say the machine is given by this processor which takes input as X, processes it by squaring it and gives you the output which is the square of that input. So let's say I have given it as an input 2. So 2 was the input. So 2 got processed, which means 2 got squared. So 2 when gets squared gives you 4, which will be the output. I'm trying to explain the concept of functions in a very layman language where you need to understand that this 2 is our input. To be more specific, I'll call it our independent variable. So independent variable means simply nothing but X. And that thing here is called the domain. Here, this is your function. So f of x is equals to x square is your function, which behaves like a machine, which processes inputs and produces outputs. And there, this 4, which got produced as an output, which is technically y here, which we call the dependent variable, which we called the dependent variable. What did I just say? X here is your independent variable, but y is called the dependent variable. Sir, why dependent? Because y is dependent on x. You can freely choose x, and that chosen x produces y. So y is dependent on x. So y is your dependent variable, and this thing over here is called the range of this function. So first of all, are you understanding the basic functionality, how a function behaves, how a function works? Everybody realizing it, understanding it? Do let me know if there is any confusion. I'll re-explain. Yes or no? So, function technically is a more special or a specific case of a relation. Sir, what did you just say? Could you repeat it? Yes, I will. Here, let's say there is a relation from A to B. There is a relation from A to B. There is a relation from A to B. So this was your set A, this was your set B. There is a relation from A to B. Let's say set A has few elements like 1, 2, 3. Set B has few elements like A, B, C, or rather I'll say 2, 5, and let's say 9. Right? Everybody listening and understanding? I'll explain that, Alpha, don't worry. I'll explain all the cases. I'll explain onto, into, many, one, one. I'll explain all the cases, don't worry. But right now, let us first of all understand what is a function. So I will explain or give you different scenarios and ask you that under what circumstances will you call it a function? So I repeat, a function is a special case of a relation where where it follows a specific definition, sir. Sir, what definition? Where it follows a specific definition that function means a special case of a relation where all the elements from the domain or in the domain have unique image. Sir, what did you just say? What did you just say? I have given you a definition of function. But sir, what do you mean by definition of function here? By definition of function, I wish to say, yes, I think Alpha has already written this. Every member of A is uniquely assigned to a member of B. Absolutely. Every member of A is uniquely assigned. These are the two important keywords here. What are the two important keywords? Let me just try and create a function and you tell me whether it is a function or not. So 1 is mapped with 5. 2 is mapped with 2. I hope you see that this is a function. Isn't it? Is it a function, students? And if it is not a function, what makes you think that it is not a function? Can you tell me? Sir, when it comes to defining the unique image, 1 has a unique image 5, 2 has a unique image 2. But in order to call it a function, there you are missing something. There you are missing something really important. What am I missing? Sir, you are missing something really important, that this 3 is an element in the domain set. These 2, 5, 9 are the elements in the codomain set. And sir, all the elements from the domain should be mapped. All the elements in the domain should have a unique image in the codomain. So sir, all the elements. Where is the image of 3? Do I see the image of 3? Do I see the image of 3? Where is the image of 3? Where is the image of 3? Image means 3 is mapped to which member? No member. So no member. Absolutely, Vijay. So is this a function? No. This is merely a relation. This is merely a relation, but this is not a function. This is clearly not a function. So sir, what exactly is a function? Okay, let's delve a little deeper. Let's delve further. Let's see whether we are able to create a function or not. So let's say there is a set A, there is a set B, and let's define few more cases. By the way, do you know the next chapter, Karnal Tripura, I'll teach will be quadratic equations, and then I'll take trigonometric functions and equations, identities, everything. So these are the 4 chapters which we have already covered in the chapter in the batch Arjuna JEE in English. So this is a backlog series which we have started. So everything which got covered already, the students who have joined us late have the opportunity to cover all these chapters. That's what we have started. Yes, Vijay, that's brilliant. Coming back to this discussion, A and B are 2 sets. Let's say A has elements 1, 2, 3. B has elements 4, 5 and 6. So sir, 1 is mapped with 4, 2 is mapped with 5, 3 is mapped with 5. Is it a function? Absolutely not, sir. This is not a function. This is not a function, sir. This is not a function. We can confidently say, sir, this is not a function. Can somebody tell me why? Sir, because look at this 2 and 3. They have an image 5. It is not unique. Yes or no? How many of you are thinking that this is not a function? How many of you are thinking that this is not a function? Sir, this is not a function because look at this 2 and 3. They don't have a unique image 5. First of all, learn and understand the concept of having a unique image. Image should be unique. What is unique? 1, 1, 1, 1. Try and understand. Look at this one. How many images does it have? 4. 1 unique image. Good. Look at this 2. How many unique images does it have? 5. 1 unique image. Fine. Look at this 3. How many unique images does it have? 1. 5. That's it. So all the elements have a unique image. So where are we violating any condition here? No, we are not. We are not. So if we are not violating any condition, is it not a function? This is. This is of course a relation, but it is a function as well. Were you able to process it? Were you all able to process it? So sir, then what is the case where you say that images will not be unique? Okay, let's talk about that case as well. So let's say here you have 1, 2, 3, you have 4, 5, 6. 1 is mapped with 5, 2 is mapped with 4, 3 is mapped with 6, 2 is mapped with 6. Here, is there a function, students? Vijay is more specific. Onto, into, many one, bijection, surjection, injection. Good, keep it up, really nice. By the way, you tell me, is this a function, students? So sir, 1 has a unique image 5, 3 has a unique image 6, but look at 2, sir, look at 2, 2 has an image 4 as well as 6. So 2 has an image 4 as well as 6. So do I see a unique image? Do I see a unique image? No, sir. No, sir. No, sir. So is it a relation? Yes. Is it a function? No. Absolutely, absolutely, Alpha. Very good. Keep it up. That's good, Vijay. That's good. So I hope now the concept of function makes much sense in your brain now. Did you all get this idea? Everybody able to process it? This question after this session, once the session gets over, I'll post in our WhatsApp group. So this question I'll post as a homework question in our WhatsApp group. And I'd like to know how many of you are able to solve this. So I'd like to see your response that out of these, how many, out of 1, 2, 3, 4, how many or which are functions? Which are functions? I will post this question on our WhatsApp channel today. So this is a homework question and we'll see how many of you are able to do it. So the link to our channel, WhatsApp channel, is given in the description. Do let me know after the session how many of you get it right. This same category of question we have already done. So I'd like to know the understanding how many of you have developed it. By the way, Alpha was asking in the beginning, sir, number of mappings, can you explain? Yes, why not? Let's say permutation and combination I'll use. So I hope some basics of PNC you know. So let's say there is this set A, there is this set B. Set A has element x1, x2, x3, x4, x5 till xn. Set B has elements y1, y2, y3, y5 till ym. I have a question. Is there a function possible if A is empty? So you are saying domain is empty. So that's a function, but there are no elements. So it's an empty function, you may call it. Good question, Alpha, by the way. I'll come to this part, but before that, I will take one more example. Let's say here we have a domain and codomain, everyone. So there I have elements like 2, 3, 4. Here I have elements like 6, 7, 8, and 9. Now, if I want to do mapping here, I want to create a function here. So permutation and combination I'll do here. Everyone, please pay attention. So, sir, what do you mean by permutation and combination? By permutation and combination, I mean that look at this 2. If I approach this 2 and ask it, how many choices do you have? So what will 2 say? Sir, 2 will say that you can map me either with 6 or 7 or 8 or 9. Mind you, students, I'm not saying and, I'm saying or. Or means I am saying 2 has either this choice 6 or 2 has either this choice 7 or 2 has this choice either 8 or 2 has this choice 9. Understanding my language? So what am I saying here is that if I approach 2 and ask it that how many choices do you have? So 2 will say I have 4 choices. I have 4 choices. Absolutely, Vijay. Now let's say 2 is mapped with 6. 2 is mapped with 6. Let's say to understand it, let's say I have mapped 2 with 6. And now if I approach 3 and ask him how many choices do you have? So will 3 say that I cannot be mapped with 6? No, no, no. 3 can still be mapped with 6. It is still many to one function, yes or no? Or 3 can say I can map with 7, or 3 can say I can map with 8, or 3 can say I can map with 9. So 3 now has how many choices? So 3 also has 4 choices. Why don't you think so? 3 also has 4 choices. I hope you did understand that 3, when approached and asked how many mappings can be done with you. So 3 can say I can map with 6 or 7 or 8 or 9. So 3 also has 4 choices. Let's say 3 is mapped with 8, right? Now, again, when I approach 4 and ask him, how many choices do you have? So 4 will say what? 4 will say, I cannot be mapped with 6 and 8. No, it will not say this. 4 will say, you can map me with 6, you can map me with 7, you can map me with 8, you can map me with 9. So 4 will say that I have 4 choices again. So 4 also has how many choices, students? 4. So this 4 to the power 3, excellent Vijay, that is 64, would be the number of functions I can form from this domain to this codomain. So 4 cube is 64. So I think Alpha, you were in the beginning asking the total number of functions. This is the answer to that question. Generically, if you wish to write it, with a formula, I hope you do understand that this is your domain. This is your codomain. So if I choose elements from the domain and map them with the codomain, look at this first element, x1. It has how many choices? Sir, x1 can be mapped with either y1 or y2 or y3 or y4 or yn. So x1 has 1 plus 1 plus 1 plus 1 plus 1. 1 is added m times. So x1 has m choices. And in permutation and combination, we have learned and means multiplication. And x2 again has how many choices? So if I again approach x2, x2 will say I also have m choices. Let's say x1 is mapped with y2. So will x2 say that I will not be mapped with y2? It can be many to one relationship, many to one functions. So x2 again has how many choices? M choices. x3 also has m choices. x4 also has m choices. So m into m into m, how many times? Sir, n times. M into m into m, how many times? Sir, m times. Sorry, n times. So m into m into m, n times is m to the power n. Which means, absolutely Vijay. So if there are total n elements here, m elements here, n elements in the domain, m elements in the codomain, so total number of functions from A to B, will be m to the power n. Absolutely. Basic principle of counting, first principle of counting, permutation and combination. Excellent. By the way, Alpha, in which standard you are right now? 11th or 12th? You're preparing for ITJEE or some other exam? So I hope you remember this question I'll be giving you in the WhatsApp group today after the session. Once the session gets over, we'll be posting this question as a homework question and we'll be seeing how many of you are able to do it there. So show how many of you are able to do it there. WhatsApp group link is given in the description. You check the description of this video, you will get it, everyone. Now, once you have understood functions, let us understand domain, codomain and range, the concept of domain, codomain and range. So let's say I define a function f from R to R, which is given by x square. So sir, what are you exactly doing? I am saying that here, this is your domain. This is your codomain. So domain is your set R, codomain is your set R. So domain has a lot of elements like 0, 1, -1, like 1.5 and so on, all the rational, irrational, all sorts of numbers it has. Listening and understanding, everyone? So if I apply a function here, fx is equals to x square. So I hope you do understand that this set over here is your domain. This R is your domain, and this set over here is your codomain. So this R over here is your codomain. Everybody listening and understanding comfortably, all the participants? Sir, do we not get notes? Please take care of sending all subjects backlog class. Yes, RJpedia 2.055. All the notes are getting uploaded on our pw.live application. You just need to visit our channel and there you will get this. Everything is getting uploaded. Don't worry about that. So if I square these numbers, for example, √3 when squared gives you 3, -1 when squared gives you 1, 1 when squared gives you 1, 0 when squared gives you 0, 4 when squared gives you 16. So I hope you do realize that, sir, codomain has all the real numbers like negative, positive, 0, everything. But when I square all these real numbers, will I really get all the numbers? No, I'll not get all the real numbers. I will get only non-negative numbers. So when numbers are squared, when numbers are squared, when numbers are squared, when numbers are squared, the set of squares of numbers when you get is going to be only positive numbers, which means this set here is the set of all the numbers from 0 to infinity including 0, because when you square a number it is always non-negative, which means either 0 or greater than 0. Processing this data, students. So this set 0 to infinity is called the range. So first of all, try and learn the difference. Range and codomain are not same. A lot of students in our Arjuna batch are still telling us, when they were learning it for the first time, were telling us that sir, range and codomain are same. This is what they were told or taught. And they were saying that our teachers in their schools have said this. I don't believe this. A teacher would teach something like this. I totally don't believe this. But if you are mistaken here by confusing relations or functions as domain and range to be same, you need to correct it. You need to correct it. Range and codomain are not same. Look at the definition. It follows a very standard definition. Whatever inputs you can give is your domain. Whatever outputs you can produce is your range. Simple. Then sir, what is the scenario of codomain here? Codomain is given by the question setter. The person who sets the question gives you a definition of the function where it says that your inputs will be chosen from this set, outputs will be chosen from this set. So the set from where outputs are chosen is your codomain. The set from where inputs are chosen is your domain. But from that codomain, there are the elements which are the images of the inputs. For example, in codomain, there is an element, let's say -3. So can you really see a number when squared gives you -3? No. So I don't see any pre-image of -3. Pre-image of -3, which means there is no number which when squared gives you -3. No. So -3 is still a part of codomain, but -3 is still a part of codomain, but it is not a part of range. Alpha, no. Range is equals to codomain does not mean 1-1 function. Range is equals to codomain means onto function. 1-1 function is a different scenario. I'll clarify that, don't worry. But did you all get this? Did you all understand this? Shall I re-explain this part, all the participants? Have you all been able to process this idea? Yes or no? Yes or no? Everybody, quickly, let me know. I will now start explaining different types of functions to you so that we can start understanding the different categories of functions here. I will begin with monomial function. What is a monomial function here? Krong's official, sir, I have total, absolute, honest and genuine empathy for you if you are genuinely putting it as a concern. Trigonometry, that means trigonometric ratios, identities, functions, equations, inequations, everything will take in the next week. So in the next week, we'll take two things, quadratic equations backlog and trigonometric functions backlog. Yes, definitely Vijay, that's exactly what I've said. For a function which is y is equals to x square, you won't see any number which when squared gives you a negative number. Good Alpha, that's great. So everybody got this? I am now coming to this part where we are discussing a monomial function. So monomial means, like I hope you have heard the binomial. So mono means 1, bi means 2. So mono means 1 means if a function or expression contains only one term, like y is equals to x square, y is equals to 2x, y is equals to minus x. These are called monomial. So from monomial, we introduce next thing, which is called polynomial. So what is a polynomial? Sir, I have backlog on set chapter. Can I start relations and functions? Karnal, Tripura, you can. And then you can watch the chapter sets after this one shot or this live video. Sets I have just, I think, recently taken in the last class where I was not feeling really well, but I have taken one shot there in a more very good, detailed and insightful manner, as clear as I could take. So after the session on relations and functions gets over, you watch sets as well so that you get complete clarity. Come back everyone, here we are. Polynomials you must have studied already in I think 8th and 9th standard. What did you study? I hope you do remember. If I'm given something like this, let's say f of x is equal to x square minus 2x plus 3. So this is called a polynomial, which is a polynomial in x. More than one terms are there. Highest term, highest degree term. So highest power of x which I can see is 2. So this is a second degree polynomial. Second degree polynomial means quadratic, 3 degree means cubic, 4 degree biquadratic, degree 5 is pentic, and so on. So Krong's official is saying, okay sir, thanks a ton if I am messaging like this. This is very genuine way. No teacher will respond to this message. You are the only person I've told message. Very thank you sir. Same here, Krong's my friend. Same here. That's good. It will be a quadratic. So I am saying that we will see polynomial functions as well. And now I'll start explaining polynomial functions and all. So when you look at this function, y is equals to x square, as we have just, I think, started our discussion with this. You look at this, can I not try all the values from minus infinity to plus infinity? Yes, sir, we can try all the values. Vanita, my friend, we will take all the classes. Don't worry. Right now, if you visit our live section, before this backlog series, we have been conducting live classes for class 12 standard. All the chapters we are intending to cover. And very soon we'll start 11th class live classes as well. But this is the backlog series right now going on. Okay, Vanita? Now coming back to this discussion, whatever values of x I can try. I think I can try all the values. I can try all the values of x. Whatever number you want, you can square any number. So if I can put x as any real number, that means domain here I'm willing to define. So domain for this y is equals to x square will be all the real numbers. But as we have just discussed, when you square the numbers, the negative numbers when you square, or positive numbers you square, or even 0 when you square, squares are always non-negative. So existence of this graph, you will see only above the x-axis or along with the x-axis. You won't see the existence of this graph on the negative side of the y-axis. What does it mean? Its range. Its range is going to be 0 to infinity. So sir, what was this R? This R was defined by the person who said this statement. So there he said that this R is the codomain. So are you understanding the difference between codomain and range? This is the domain. Domain means inputs. Range means outputs. I hope you are processing this idea. Everybody got this? Now let's talk about cubic. So cubic means f of x is equals to x cube. Their domain and codomain both are R. So if I draw the graph of x cube, f of x is equals to x cube, what I clearly notice is that sir, on the x-axis, I see the existence of the graph to be everywhere. I see the graph exists everywhere, which means I'll say that from minus infinity to plus infinity, I can clearly see the graph exists everywhere along with the x-axis. Which means its domain is going to be all the real numbers. But when I look at its range, so range means existence of the graph along with the y-axis. So sir, along with the y-axis, we see its existence again everywhere. So if I see its existence everywhere, I will say this is having range also to be R. Because when you cube a number, you will see numbers coming from minus infinity to plus infinity. Getting and understanding this idea, everyone, all the participants. Any confusions on a cubic function, please respond. Now there comes a very beautiful function which is called a reciprocal function. Reciprocal function is given by y is equals to 1 by x. Now there is a problem. Its domain is not R. Its domain should be R minus 0. So there should be a small correction here. Let me just correct it. Give me a moment, everyone. Its domain is not R. Its domain should be, function should be R. I hope you're listening and understanding. This function should be defined from R minus 0 to R. And of course, codomain you have taken as R, but range will be R minus 0. So what are you saying? Can you explain this? Yes. I am saying the function is given by 1 by x. 1 by x means what? If x is 2, y will be 1 by 2. I hope you're understanding. This is what I'm talking about. So, sir, when you talk about a reciprocal function, don't you think that you cannot take x as 0? Yes, of course, because x is technically there in the denominator. So if it is there in the denominator, can we really afford to keep the denominator to be 0? Never, 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 never. Yes or no? So first of all, the first thing which I'll say here is that reciprocal function is not defined at 0 because 1 upon 0 is not defined. Okay, sir. Then what? Then I hope you do realize that at 1, you will see it to be 1 because x is equals to 1, y is equals to 1 upon 1, it is 1. But for all the values which are greater than 1, it will be less than 1. Imagine this, you put 2, it will be 1 by 2. If you put 3, it will be 1 by 3. If you put 4, it will be 1 by 4. If you put 5, it will be 1 by 5 and so on. Yes or no? One by 0. It depends, my friend Alpha. I'll explain that, don't worry. Very good question you have asked. I'll explain that, don't worry. Similarly, here, when you look at this value, at -1, you see it to be -1. But for all the values which are less than -1, you see them to be greater than -1. I hope you do realize it contextually what I'm trying to explain here. Thank you so much for your beautiful comment. Word of appreciation. Thank you so much. I really appreciate it. Now, Alpha, let me answer your query. Alpha is saying that when x approaches 0, what does 1 by x do? So mathematically, we say when x approaches 0, what does 1 by x do? So first of all, we know that 1 upon 0 is something which maths doesn't accept. Maths does not define it. So maths says that, okay, you are wanting to know that 1 by x, what would it be when x is going towards 0? So we call it seeing the trend, we call it seeing the pattern, we call it seeing the observation that where is it going, where is it leading. So we say that if x is approaching 0 from left hand side, we look at the curve, it is going downward, 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 so it is going towards -infinity. So we say that when x is approaching 0 from its left hand side, 1 by x approaches -infinity. This is how we write it in mathematics, Alpha, but this is what I could teach you in 12th standard. Right now you are in 11th, so I would not teach it like this. I would avoid discussing it, but in calculus we do discuss it. For example, if 0 is approached from the right hand side of 0, so when you approach 0 from the right hand side of 0, the curve goes up and up and up towards infinity. So this thing mathematically is written as limit x is approaching 0 from its right hand side on 1 by x, then it approaches plus infinity. So when you say positive infinity, negative infinity or not defined, it is simply this. Is everything fine? I think I stopped. Let me just read it. I think everything is going smooth. कुछ हुआ क्या विजय? पॉज हुआ? सही चल रहा है देखना. मैं कंटिन्यू करूं? आप तो कंटिन्यू कीजिए. कुछ दिक्कत हुई क्या स्ट्रीमिंग बताना. Students, just write in the comments. Are we clearly visible and audible, students? I think my screen got frozen. So it froze. I hope it is fine at your end. Everybody can hear me. Everybody can see me. Everybody give me a quick response. Is it going smoothly? I hope you understood this concept. This is for you only, Alpha. I would simply avoid discussing it, but you asked for it, so I explained it. Others, limit does not exist. Very good, Vijay. Very good. Excellent. So why are we saying that limit does not exist? Because I hope you do realize that from left, it is approaching -infinity. From right, it is approaching infinity, and -infinity and infinity are simply not same. Even two infinities are not same. Great, 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 great. Thank you so much, Tripura, Alpha, Vijay. Thank you so much. Thank you so much, Pranjal. So I hope you do realize that, sir, here in this function, 0 cannot be accepted as a value of x. Same when you look at the graph, it exists on all the values of y which are negative, all the values of y which are positive, but y is not 0. Y is technically 0 when x is either plus infinity or minus infinity, which means what? If I talk about domain, it can take any real number except for 0. Same as with range, it can take any real number except for 0. Now, sir, what is a constant function? Constant function is a constant function, sir. What are you saying? Let's say I take a function y is equals to 3. I take a function fx is equals to 3. So this will be a function, let's say, which is passing through 0, 3 or 0, c in this case, which is technically a line parallel to the x-axis. So whatever value of x you take, it will always give us the same output. So first of all, sir, can I take any value of x? Yes. So what will be its domain? Its domain is going to be all the real numbers. But sir, when you take any real value of x, what is the output it produces? It is producing one single constant output, which is 3 in this case, or could be c in, depending on the case, whatever the value of c is. I did not get this. Okay, anyways, Alpha, can you be more specific, whatever you have written? I did not get this, but I hope everybody understood it. Now there comes an identity function. I hope in 10th, probably you must have studied this idea in coordinate geometry, the straight line y is equals to x. Have you studied it? So when you look at this curve, y is equals to x, which means f of x is equals to x. Identity function. Do you remember identity relation 1, 1, 2, 2, 3, 3? Similarly, if I talk about identity function like 1.1, 1.1, root 3, root 3, 7 by 2, 7 by 2, 5, 5, minus 10, minus 10, if something is mapped with itself. So I hope there is no problem in pushing any value of x. So it will exist from minus infinity to plus infinity, which means I can try any value of x. So if any value of x can be tried, its domain will be R. But sir, when you talk about its range, I think if x is pushed, the same y gets generated. So y will also be the same x, which means if x is any real number, y can also be any real number. What does it imply, students? Sir, it implies that its domain and range both are real numbers. And I hope in coordinate geometry, you do see it as a straight line passing through origin, having 45-degree angle with positive x-axis in anti-clockwise direction, which means slope will be 10, 45, 1. I hope you do remember it. Y is equals to mx plus c form, you can call it, where y-intercept is 0. Everybody with me so far? Any doubts if you have, please ask. Yes or no? Yes or no? Yes or no, everybody. Now something really important and insightful I'd like to discuss with you all. This is that result on which IIT JEE every year asks a question. Sir, what is that? This is something I'd appreciate that if you remember, if you could remember. Absolutely, Alpha, you were right. You were absolutely correct. Keep it up. Now, I am saying a very crucial result here that whenever somebody says functional definition, it is functional definition based questions you are given sometimes. Whenever somebody says that f of x into f of 1 by x is equal to f of x plus f of 1 by x. If something like that is given, then we can always say that f of x is either 1 plus x to the power n or f of x is either 1 minus x to the power n. Now, sir, how do we decide whether it is 1 plus x to the power n or 1 minus x to the power n? That data will be given in the question. Sir, how do we decide what is the value of n? Is it 2, 3, 4, 5, 6? That data or information will also be given in the question directly or indirectly. So, sir, what are we supposed to remember? You are supposed to remember this as a result, that whenever a question says that f of x into f of 1 by x is f of x plus f of 1 by x, then don't hesitate in taking f of x directly as 1 plus minus x to the power n. Now, to get rid of plus or minus, one sign you need to take, or the value of n, all you do is simply solve question with the help of given data and you'll be able to crack it. Trust me. Did you all get this? Did you all understand this? All the participants, yes or no? Everybody give me a quick response. With this, exponential function will quickly understand. Exponential function is defined into two categories. For example, look at this. If I say there is a function y is equals to 2 to the power x. So look at this. 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. I hope you are clearly seeing an increase. 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32. So if I define a function which is an exponential function where base is greater than 1, it increases like this. So how does it look like? It looks like y is equals to a to the power x, where remember this, that a is strictly greater than 1. So when a, the base is greater than 1, the higher power you give, the higher value it generates, powers of exponents, powers of compounding. So all what I'm saying is, please pay attention everyone, that the moment you see base to be greater than 1, it is going like this. But if in this same function y is equals to a to the power x, if you ensure that the base is between 0 and 1, if the base is between 0 and 1, for example, 1 by 2 is the base. So 1 by 2, if it's a base, so 1 by 2 is like 0.5. So in this case, base is between 0 and 1. So if you raise it to higher powers, for example, 1 by 2 to the power 1 is 1 by 2. 1 by 2 to the power 2 is 1 by 4. 1 by 2 to the power 3 is 1 by 8. 1 by 2 to the power 4 is 1 by 16. So I hope you realize this is greatest, 0.5, 0.25, 0.4. Sorry, I'm really sorry. This is 1 by 4, right? So 1 by 4 is 0.25. This is 1 by 8, 0.125. This is 1 by 16, even smaller. So the higher powers you are going to take now, the lesser values you will generate. Are you processing this? I'll explain it. Give me a moment, everyone. I am saying that if I wish to define a function which is y is equal to 2 to the power, let's say x, and one more function I'll define, let's say y is equal to 0.5 to the power x. Look at these two cases now, right now. Everyone, please pay attention. This blue one which I have drawn is 2 to the power x. So the higher power I give it to you, the higher value it attains. But when you look at 1 by 2 to the power x, this orange curve is y is equals to 1 by 2 to the power x. Yes, exponentially increasing and exponentially decreasing. Excellent alpha. So I hope you do realize that, see the way it decreases. But sir, don't you think that it is converging with x-axis? It is becoming 0. You're mistaken. Again, the more you zoom it in, you will see the difference. Sir, okay, sir, afterwards it is constantly decreasing. Yes. So somewhere it will again merge on x-axis. No, it looks like it is merging with x-axis, but it is not. There is a difference. There is a difference. So I hope you do realize that it looks like this. And this is exactly what I say in one of my batches, that I give them this example. I give them this example of, growing 1% every day and deteriorating 1% every day. Let's say I just play with this number 2. I just keep it as simple as, let's say, 1.01. I keep it as simple as that. And this I keep as, let's say, this I keep as 1.01. I wanted to write it as 1.01. I hope you must have seen one more difference, one more very beautiful difference here, that if I keep it 1, it becomes constant. X to the power x. Both are variable technically. I'll draw it and show it to you, Alpha. Very beautiful example you have asked. Yes, a lot of things you are telling with this. Excellent, excellent. So one more thing I wanted to discuss, 1 to the power x. So 1 is base. So if the base is 1, I have fixed it. So 1 raised to any power is 1. So this is a constant function. By the way, I am saying 1.01, let's say you take, and there you take, let's say 0.99 for a while. So I just wanted to show you these two curves. Look at these two curves. Something really beautiful we'll be noticing now. Please pay attention, everyone. Now the orange curve and the neon curve, or indigo you'll call it. So two curves we have, the orange curve and the indigo curves. They both look same. Initially, they both look same, but when you zoom it in, or when you go further, and when some days pass by, do you realize this orange actually is deteriorating and this indigo one is actually enhancing or improving? This is a line or a statement I have read in one of the books, The Power of Atomic Habits. James Clear, I think, was the author. He said that if you improve by 1% every day, after a year, I think 365 days, you will be 38 times of yourself. Wherever you stand today, you will be 38 times of that if you just keep improving by 1% every day. But if you keep deteriorating by 1% every day, look at how pathetically you have declined. After, let's say, almost 365 days, this is where you will be. This is the potential you have reached of yourself, 0.02. I mean, if you were 100, you have become 0.02. Can you believe this? So that's the power of compounding, we say. So even if you're getting 1% better every day, you will be exceptionally well after a year. So those who are losing hopes, are getting demotivated, we don't want you to put 12 or 14 hours of efforts every day. Just be consistent. Yes. Rate of growth of bacteria, exponential. Napier's constant, E, E comes into picture there. So I think let us get back to exponential functions. And the inverse of exponential, I hope so far you can see this, that from this curve only we can deduce that a to the power x can be defined for any value of x from minus infinity to infinity. So what about its domain, sir? What about its domain? If I wish to define its domain, I'll say its domain will be all the real numbers. Sir, but what about its range? I hope you must have seen the range. It either keeps on declining, or it keeps on increasing, but it never matches with the x-axis. So it never meets the x-axis, which means what? It is always positive. It is always positive means 0 to infinity. My teacher, when I used to prepare for ITJ, used to say that effectively how many hours you are studying, that matters. Janit Shrisai Hota, I think I'm pronouncing your name correctly. Effective hours, efficient hours of your preparation, count those. You may sit for 8 hours and you don't learn anything. Or you may sit for 2 to 3 hours and effectively you learn something. That's more important. So don't count hours. Count your efficacy, your effectiveness, how efficient you are. That matters. Everybody got this? Shall I move ahead from here? Then similarly, there is a logarithmic function as well, which is inverse of exponential functions. You do know it, right? We have done it in basics of maths as well. So if y is given as a to the power x, then logarithm says, or let's say, let me write opposite now. Let's say if I'm given log x at base a is equals to y. So NT-log says that this a raised to the power y is equal to x. This a raised to the power y is equals to x. So exponential and log are inverse of each other. Exponential and log are inverse of each other. If you want more clarity, I'll just take one example. Let's say we know 10 cube is 1000. So I'll say log of 1000 at this base 10 will be 3. So this is how you relate logarithmic and exponential function. Why don't we use ln for natural logarithm in our book? In which book? Alpha. In mathematics, we use E only, the Napier's constant, which was developed by the mathematician Napier. 10 is a base which we use in chemistry and physics. But in mathematics, we use E only. So in mathematics, if you ever see something like log of, let's say, 50 and no base is mentioned, then you take the base as E. But in physics or chemistry, if the base is not mentioned, you take it as 10. Everybody got my point? Everybody? Yes or no? All the participants. So here, I think you have understood exponential and logarithmic are simply inverse of each other. So when you talk about inverse, this is how you draw the graph of log x. So a to the power x had a range 0 to infinity. That will become the domain now because it is the inverse. A to the power x had the domain minus infinity to infinity. So that will become the range now because it is the inverse. Understanding my language, everyone? So I am saying a simple fact or a simple statement here. Please pay attention, everyone. That here for log x, of course, it depends on the base. It clearly again depends on the base. If you are defining log x at base a as a function, so if your base is greater than 1, this will be the graph. If you are defining log x at base a as a function, and if the base is between 0 and 1, this will be the graph. But in both of the cases, sir, you must be noticing that x can be taken from 0 to infinity only, where 0 is open. So domain, if I wish to define for logarithmic function, it will be all positive numbers, which means argument, the input which you can pass to log, will always be positive. But sir, when you talk about the range, range, I hope you all must have noticed, sir, I can produce all the numbers on the y-axis. From minus infinity to plus infinity, I can travel all the way, which means range will be all the real numbers. Everybody got it? Everybody understood it? Any confusions you have, please ask. Do let me know if there are any queries or concerns. Shall I move ahead from here, all the students? Now, trigonometric functions I'll cover separately in trigonometric ratios, function and identities. Don't worry about that. Let's come to some piecewise functions. The absolute value function, the modulus function, students. Remember that? I repeat, trigonometric functions like sine, cos, tan, cosec, sec, cot, their graphs, their domain, their range, properties, periodicity, everything, odd, even, I'll cover in trigonometric functions, which we'll study in the next week. Right now, I'm skipping it here. So what are we doing here, sir? Let us now focus on absolute value function. So let's take a 10 minutes break and then we'll resume afterwards. Is that okay if I do so? So let's quickly do a break or take a break and then we'll resume. You also hydrate, walk a little, stretch, roam around, eat something and then come back. Okay. So if you all can hear my voice, come back. I hope you all can see me. I must be visible to everyone. Am I clearly audible? Come back, everyone, come back. So the break is over. I'm sure you must have had a good break, roamed around, walked a little, had something, hydrated yourself, stretched, and we all are back with this one shot of relations and functions for class 11th. This is not class 12th relation and functions. This is class 11th relation and function for IIT JEE Arjuna batch. Backlog series. Sir, what do you mean by backlog? This is already covered in Arjuna batch. Sets, relations, functions, quadratic, trigonometric functions we have just done today only. We conducted an extra class as well. So it all got over. So now if you are joining us in Arjuna batch, you can watch these one shots so that you can cover us. Although recordings are there of those long, lengthy, complete, comprehensive sessions as well, where we have practiced a lot. But if you miss some practice, which of course one shot will not be able to cover because it is merely a one shot, which will give you the conceptual clarity, but practice you need. For that, you need to do a lot of practice. So practice means PYQs, yes, or more appropriate apt questions, yes, depending on what level you are at. And that's exactly where our feature in Infinity Plan helps you with infinite practice, that you can practice as many questions as you want, depending on your requirement with the Infinity Plan, with the Infinity Practice. Well, coming back here, we are now going to discuss absolute value function, or we call it modulus function. For example, let's say if I ask you the magnitude of 2.3. So 2.3 is actually plus 2.3. Thank you so much, Shashank, my friend. Thank you so much. I really appreciate it. So if I just take the numerical part from plus 2.3, I remove plus, and if I just look at its numerical value, its absolute value, that's 2.3. Let's say if I look at minus 3.7. So with the signature, it is minus 3.7. With the signature, it is minus 3.7. But if I remove this signature sign and I just consider its numerical part, that's 3.7. So that's its absolute value. So what is an absolute value function here, or modulus function? It gives you the numerical part of that number. I hope you are processing this idea. I'll repeat. Have patience and listen to me very carefully. I am saying that we treat it like this. We technically treat it like this, that when we say absolute value or numerical value you are taking. So let's say if I'm taking absolute value of 2.3. So just check whether this 2.3 is negative or positive. So 2.3 is greater than 0. So just write 2.3 as it is. But let's say if you are taking modulus of a negative number, which means I know that minus 3.7 is negative. So put a negative sign over this negative number so that it becomes non-negative. Yes, Shashank, but they are incomplete. I think I have covered a lot of things there, but few chapters I have not. So it's always good. I have covered them thoroughly and comprehensively in a very detailed, in a very insightful manner. So it is always a good idea. Rest we are covering here, right? So I hope you got my point. What is an absolute value function? What is a modulus function? It gives you the numerical value, the absolute value. So how do we define it? We say that it is given by mod of x. So as long as x is non-negative, it is x. But if x is negative, it is minus x. There is a small correction. I hope you got my point. So if you draw the curve, you draw it in two parts. Yes, Shashank, I think I have answered your query. So you draw it in two parts, which means as long as x is positive. When is x positive? Here, between 0 to infinity. So it is y is equals to x. As long as x is negative, between minus infinity to 0, it is y is equals to minus x. These two straight lines you must have seen already in coordinate geometry. If I'm talking about y is equals to x, that is clearly a straight line passing through origin, making 45 degree with positive x-axis in anti-clockwise direction. But if you look at y is equals to minus x, that's again a straight line passing through origin, but making an angle 135 degree with the positive direction of x-axis. That means slope is minus 1, slope is plus 1. Did you all get this idea comfortably? But there comes a very important, a very insightful significance of this modulus, where we treat it in terms of difference. What do I mean by that? Let's say if I ever say that this is 0 and I say mod x is equal to 3. So we say that I'm looking for a number whose magnitude is 3. Or I can say I'm looking for a number whose distance from 0 is 3. So minus 3 is also 3 distance away from 0. 3 is also 3 distance away from 0. So if somebody says, thank you so much, Shashank. If somebody says mod x is 3, we say x is plus or minus 3. I hope you're understanding it. Let's say if somebody says mod x is greater than 3. So this time I'm looking for those numbers which are more than 3 distance from 0. So this is 3 distance from 0. So more than 3 distance means all the numbers on the right of 3 or all the numbers on the left of 3. So there I'll say x will be either greater than 3 or x will be less than minus 3. One more way, please pay attention everyone. If somebody says that mod x is less than equal to 3. So I'm looking for those numbers which are either 3 unit distance away from 0 or less than 3 unit distance. So 3 unit distance away from 0 is still either minus 3 or plus 3. So anything between 3 or minus 3 will be 3 units distance away from maximum 3 units distance away from 0. Did you all understand these inequalities as well based on modulus, which we'll be using in future in questions like this? From this concept of distance, that mod should be treated as a concept of distance. Everybody, any confusions? Please ask if there are any doubts. Shall I move further from here? Shashank is saying, sir, I'm in Arjuna 2.0 2026. I was watching your lectures. Thank you so much. Definitely not. We all are good. We all are fine. We all are simply decent, standard, ordinary teachers who are just trying to help you in your journey. By the way, thank you so much for your feedback. Now, let us get back to Singham function. One of our students, his name is Balaji, in class 12th, Laksh batch. He calls it Singham function. It is actually Signum. So Signum here means you define it as mod x upon x as long as x is not 0, or you define it as 0 the moment x is 0. So if x is positive, mod x will be x, so x upon x will be 1. If x is negative, mod x will be minus x, so minus x upon x will be minus 1. And if x is 0, they define it as 0. So do you see it as a combination of 3 different constant functions? So as long as x is positive, it will be 1. As long as x is negative, it is minus 1. And the moment x is 0, it is 0. So this is how you see its graph. Everybody listening, understanding it, everyone. So here I hope you do realize that it is a discontinuous function. It breaks. For negative values of x, it is minus 1. For positive values of x, it is 1. At 0, it is 0. So sir, what about its domain? Sir, if you talk about its domain, don't you think that its domain is all the real numbers? It is defined for negative real numbers, positive real numbers, 0 as well. But sir, what about its range? What do you think of its range, sir? What do you think of its range? Its range are 3 numbers only, merely 3 numbers, either minus 1, 0 or 1. Everybody processed this idea. Good, excellent, excellent. Keep it up, really nice. Now there comes again a very beautiful function which is called GIF. It is not that meme wala GIF. It is a different kind of a GIF. It is called the greatest integer function. Now what does it mean? This here means that, let's say if I ask you GIF of 2.3202. So look at 2.3202 on the number scale. There is 2.32, yes or no? So either this number or just less than this number, whichever is the greatest integer, just choose it. Let me redefine it with better explanation. I am saying on the number scale, you will find 2.2, 2.3, 202. So just on the left of it, there will be 2, 1, 0 and so on, a lot of integers. So among these integers, including this number, if it is an integer, which one is the greatest? So sir, I clearly notice that among all of them, 2 is the greatest. We all do notice it. So if 2 is the greatest, GIF of 2.3202 will be 2. Shall I repeat that? Definitely, Shashank. Someday I will, but it will be too late. So don't rely on anything like that. Right now, focus on what we are doing. It will definitely help and assist you. I totally get your concern, but right now, focus on whatever possible ways we can assist you with, right? Now, you look at this 0.23. So if you look at 0.23 on the number scale, this is 0.23. On the left of it, there is 0, -1 and so on. So including 0.3, look at the greatest integer among all the integers which are less than or equal to it. So among them, the greatest is 0. So GIF of 0.23 is 0. So this GIF sign is given by a parenthesis, but not always a parenthesis would mean a GIF. It should be specifically mentioned in the question that this parenthesis sign represents GIF. If it is not mentioned, I'll not take the parenthesis sign as a GIF. For example, look at 5. So on the number scale, this is 5, this is 4 and so on. So is a 5 an integer? Yes. So among all the integers which are less than equal to 5, which is the greatest? 5. So GIF of 5 is not 4. Please understand, it will be 5. For example, GIF of -8.07. So look at this number scale. This is -8.07. So on the left of it, there is -9. On the right of it, there is -8. So among these integers, including this, whatever are less than it or equal to it, which one is the greatest? Sir, -9. Is it an integer? No. So the greatest is -9. So GIF of -8.07 will be -9. Is everyone able to process this idea, or are you feeling confused? Do let me know if there is any query or confusion. Students, did you all get that? Similarly, -0.6. If you locate it on number scale, this is -0.6. On the right of it, there will be 0. On the left of it, there will be -1. So among all the integers which are less than or equal to it, which one do you see as the greatest among them? -1. So -1 will be the GIF of -0.6. Did you all understand the concept of GIF, or are you still feeling confused? So when you look at the graph of GIF, how do you draw it? How does it get drawn? So I hope you do realize between 0 to 1, it will be 0. But at 1, it will be 1. Between 1 and 2, it will be 1. But at 2, it will be 2. Between 2 and 3, it will be 2. But at 3, it will be 3. And so on. Yes or no? Similarly, between -1 and 0, it will be -1. But at -1, I hope you understand. I repeat, at -1, it will be -1. But at 0, it will be 0. Between -2 and -1, it will be -2, but at -1, it will be -1. Are you understanding my language, everyone? So for GIF function, if you ask me its domain, what do you think, sir? I think I can take GIF of any real number, so its domain will be real number. But what about its range? Mind you, students, its range. Its range is all the integers only. Because look at the graph, its steps. It is also called a step function. Absolutely, Vijay. Very good observation. So there we call it step function because it clearly gives you these integral values like steps. I hope you can see them. So output, the range will be only the set of integers, not all real numbers. Everybody got it? Now there comes one more very beautiful concept, which is called fraction part function. To understand it, let us develop a theory first. In mathematics, we say that any number comes out from its GIF and its fraction part. What did I just say? I said that if you ever write a number, let's say 2.3, so it will be a combination of its integral part and its fraction part. So if I ever say that 2.3 is a number, so 2 is its GIF and 0.3 is its fraction parts. And fraction part is defined by curly brackets. It should be mentioned in the question. Good morning, Miss Neetu. Good morning. Good morning. So coming back to this, what am I saying here is that this parenthesis is reserved, although it should be mentioned in the question for GIF. This curly bracket should be mentioned as reserved for fraction part function. So from here, let's say, that's good, Vijay, that's very good. If I wish to define fraction part function, I'll say it will be given by x minus GIF of x. So for example, I ask you some values. For example, if I ask you some values, for example, if I ask you the fraction part of 3.7, what will be your answer? Sir, it will be the number 3.7 minus its GIF. So fraction part of 3.7 will be 3.7 minus 3, which is 0.7. Okay, sir, we got it now. Okay, sir, we got it now. Okay, if you got it, do let me know. What do you think would be the fraction part of 4? Sir, fraction part of 4 will be 4 minus GIF of 4, which is 4 minus 4, which is 0. So, sir, we got it now. We totally got it now. You ask us. Whatever you want to ask regarding fraction part, please ask. Okay. So, what if I ask you, what is the GIF of minus 2.3? What do you think? 0.3? What do you think is the fraction part of minus 2.3? Students, let me know in the comments. Fraction part of minus 2.3. Be quick. Sir, as per the definition, as per the definition x, which is minus 2.3 minus GIF of x, which is GIF of minus 2.3. So as per definition, it is minus 2.3 minus 2.3 is GIF. I hope you do remember this is minus 2.3. On the right of it, it is minus 3. So its GIF will be minus 3. So technically it is 3 minus 2.3. And 3 minus 2.3 is not 0.3. It is 0.7. Absolutely, Vijay. Excellent. Very good. Did you all get this? If you were mistakenly taking the fraction part of minus 2.3 as 0.3, it is not 0.3. It is 0.7. Why? Follow the definition. Let's take one more example so that you get a complete crystal clear clarity. Let's say if I ask you the fraction part of minus 5.2. So just follow the definition. The number minus its GIF. Everybody processing this? So sir, the number is the number, but minus 5.2's GIF is minus 6. So 6 minus 5.2 is 0.8. So did you all get this? Did you all get this? How is this fraction part function behaving? Now, I hope you all must have noticed one thing very beautifully, that however it behaves, sir, it stays between 0 and 1. I mean, I hope you do realize that here, 0's fraction part will be 0, 0.1's fraction part will be 0.1, 0.2's fraction part will be 0.2, 0.3's fraction part will be 0.3, 0.9's fraction part will be 0.9, but fraction part of 1 will be 0. Fraction part of 1.1 will be 0.1, fraction part of 1.1, 1.2 will be 0.2, fraction part of 1.3 will be 0.3, fraction part of 1.9 will be 0.9, but fraction part of 2 will be 0. Although it is not very well drawn, let me just correct it because there is a mistake. Let me just get it corrected so that you don't feel confused. The graph will not go from here to here. Let me just correct this mistake. It is all going fine, except although they are knitted very close. So that's a problem. So I'll just show this graph on a different page. Let me just delete it because there is some correction here. So I'll just draw it, don't worry. I'll draw it for you, don't worry. So let's say this is your x-axis and this is your y-axis. And here you see some integral points like minus 1, minus 2, 0, 1, 2, 3. And this is a point 1. So it goes like this. Between 0 and 1, it is y is equals to x, but at 1, it is 0. Between 1 and 2, it is again that same line parallel to it, but at 2, it is 0. Between 2 and 3, it is same line, parallel lines there. Between minus 1 and 0, it is same line, but at minus 1, it is 0. Between minus 2 and minus 1, it is the same line, but at minus 2, it is 0. Absolutely, absolutely. So I hope everybody again realizing this conclusion that sir, the graph exists from minus infinity to plus infinity. So what do you think of its domain? Its domain is all the real numbers. But sir, what about its range? So, sir, if you locate its graph, I don't see the existence of the graph here. I don't see the existence of the graph here. The graph exists on this portion only. I hope you notice it. So its range is going to be what? So all the values from 0 to 1 where 1 is open. Everybody got this? Everybody understood it? Any confusions if you have, please ask. All the participants, do let me know. Do let me know if there are any queries or confusions. Now let us quickly solve some questions and get some more clarity on domain and range based questions. Although this whole chapter will cover completely in relations and functions, as relations and functions, technically as functions in class 12th, where domain, range, odd, even, periodic, one, many one, into, onto, everything we'll discuss in detail. But right now, whatever basics are needed, those I have covered, and we'll consolidate all of that with some questions. Everybody, are you all set? Shall we, everyone? So let us quickly solve few questions. Again, a very simple, very direct standard questions I've kept just to make you understand the concept. Let's say this is a question which says f of x is under root 2x minus 3. They are asking its domain. So sir, if anything is given inside an under root, that thing should remain positive or rather non-negative. So 2x minus 3 should remain non-negative. So x should be greater than equal to 3 by 2. And mathematically we write it as that x should be anything between 3 by 2 to infinity, where 3 by 2 is included, infinity is excluded. So this is how you write it. Everybody got this? Everybody understood it? Shall we try some more questions if you have gotten some clarity on this, all the participants? Second question here. When it says fx is equals to 1 by x minus 2. So we know that for rational functions, the denominator should not be 0. So we say that x should not be 2, which means here the domain will be, it can take any real number except for 2. Are you processing this idea, everyone? Simply, comfortably, directly. Remaining two questions I'm giving you as homework. You try them by yourself at home and would really appreciate if you could figure the answers out. Everybody, give them a try. Now there, let's solve one more question here. Let's try and find the domain and range of this function. It is a composite function, so don't get scared by it. Although this is log of sine of x, right? So sine I'll teach in the next class, and trigo in next to next class. But I'll take some clarity here. I'll give you some clarity here. Sine x, although you don't know its graph, I'll try to give you some clarity on it. Don't worry. If I first of all give you the graph of sine x. So when you look at the graph of sine x, it goes like this. It goes like this. It goes like this. So this is 0, this is pi, this is 2 pi, this is 3 pi, and so on. So when you notice the graph of sine x, what you clearly observe is that sir, it is positive. That is, it is between 0 and 1, between 0 to pi, then 2 pi to 3 pi, then 4 pi to 5 pi, and so on. And it is negative. It is negative. That is from minus 1 to 0, between pi to 2 pi, then 3 pi to 4 pi, and so on. Range as well, Vijay. I think I have already covered this part on PW English Medium channel as well. Do you remember that, Vijay? You were there in that class. So just go through that class. I have covered that section there. Here I'm trying to cover it from 11 standards perspective in a very simple manner. So that's why we are keeping it restricted. The whole part, domain, range, 1, 1, onto, many, 1, into, even, odd, periodicity, composition, inverse, all of that we cover in 12. So that's why I'm keeping it a little light here. Got my point, Vijay? So here I'm saying that if you notice something, what we are noticing is that sine x is showing us three kinds of behaviors, which means sine x is showing us three kinds of behavior. It is positive, it is 0, and it is negative. It is positive whenever x is from either 0 to pi or from, I hope you're noticing, 2 pi to 3 pi and something like that. That generalization I'll give you. It is 0 at any multiple of pi. It is 0 at any multiple of pi. And it is negative between pi to 2 pi, between 3 pi to 5 pi, like that. Between pi to 2 pi, and then 3 pi to 4 pi, like that. So, sir, how do we generalize it? How do we generalize it? Let us help you with that generalization. So everyone, please pay attention. The generalization is really simple and direct. If you look at this part, if I try to be more specific, I'll say I have noticed three things in the graph of sine x. Sine x shows us three things. It stays between sine x I'm talking about. So y stays specifically between 0 and 1. Y becomes 0 and y specifically stays between minus 1 to 0. So it is 0 at any multiple of pi. So there we concluded that whenever x is any multiple of pi, where n is an integer, it is 0. But we said whenever it is 0 to pi, 2 pi to 3 pi, like even multiple of pi to odd multiple of pi, even multiple of pi to odd multiple of pi. So that I'll write as 2n pi to 2n plus 1 pi. If something like that is done and its union is taken, its union is taken, there we say that sign is 0 to 1, which is positive. Again, I need not say this, that n is an integer every time. Sir, when do you see sin x to be negative? It is negative between pi to 2 pi, then 3 pi to 4 pi. So what we are noticing is odd multiple of pi to even multiple of pi. So there I'll say union of 2n minus 1 pi to 2n pi. Everybody got this definition, or are you feeling confused? Are you feeling confused? This is the last question, my friend Baladur Gamanir. If I'm pronouncing your name correctly, I'm really sorry for that. So I am saying a very direct and a straightforward statement here that I have so far defined sign. Now, can we take its signum? How? Let's talk about it. So, sir, now you're interested in taking its signum? Yes, I am interested in taking its signum. So you can take its signum graphically as well, or you can take its signum through this definition, piecewise definition as well. So I am taking signum of sin x. So I'll say signum of sin x. Whenever sin x is positive, signum of sin x will be 1. Whenever sin x is negative, signum of sin x will be minus 1. Whenever sin x is 0, signum of sin x will be 0. But sir, when is sin x positive? Sir, sin x is positive for all those x which are from even multiple of pi to odd multiple of pi. So I write it as 2n pi to 2n plus 1 pi, where n is an integer which I'm not writing. Sir, when is sin x 0? Because signum of sin x will be 0 whenever sin x is 0. So, sir, sin x is 0 whenever x is any multiple of pi. Sir, when is signum of sin x is minus 1? Whenever sin x is negative. So, when is sin x is negative? Sir, sin x is negative whenever x is from an odd multiple of pi to the next even multiple of pi, which means union of 2n minus 1 pi to 2n pi. I hope I'm not ruining this person's shirt and it is visible to you all, everyone. Yes or no? Why? What's wrong? I think everything is fine, my friend. So I hope you got this. Vijay, if you have any confusions, please ask. So today, what did we do? I will summarize whatever we have done. We started our session with relations. So in relations, I started my discussion with Cartesian product. I hope you remember that. But before Cartesian product, we discussed ordered pair. Remember that? Then from there, we gradually move towards what? We gradually move towards our definition of a relation, that how do you define a relation? We discussed number of relations as well. I mean, number of subsets. And then we gradually took it towards number of relations. Remember that? And then from there, we created a special case. And that special case we called a function. Remember that, students? And from functions, we gradually move towards three important chunks, which are called domain, codomain, and range. Remember that, students? Not just that, from there, we moved towards different types of functions. So type of functions, you remember, we discussed polynomial, rational, square, cubic and all. Then we moved towards which kind of function, students? We moved towards piecewise definitions of functions as well, like modulus function, like GIF function, like fraction part function and all. Signum function also, signum you can call it. So these kind of functions which you take. I specifically avoided discussing much things related to one, onto, many, one, into, bijection, injection, surjection, injective, inverse function, composition of functions like that, because those will be discussing in a more detailed manner when we cover them in 12th standard. So this is my major coverage which we have given. This is the Arjuna batch, class 11th, which we have started. A backlog class we have conducted. Sir, why did you conduct it? Because some people have joined us late, and if they have missed it in the class, this one shot will try to give them some clarity or coverage or basics on that. Although this is not a full session or a complete session. If imagine this, if I covered it there with a lot of sessions, which I'm summarizing with 2 to 3 hour session, of course, it does not do the justice, but still, it can make you understand some things. That's what my motive or intent was. So if you have any queries or concerns, do post them in the chat box. Otherwise, we'll call it a day. I hope so far whatever we have done is very well understood by you all. Now, my expectation after this is you will be two category of students, whether you are an Arjuna student or you are a non-Arjuna student. If you are an Arjuna student, then you could be of two categories. Either you have recently joined us, that means you are a new joinee, or you are our old students who are their existing students. So old students, if you have still not practiced modules or PYQs, then this should be the order of yours. The new joinees who have recently joined us, I will say simply practice DPPs as of now. The non-Arjuna students, you have two choices. Either you can enroll, which is totally your choice. And if you don't enroll, what you can do is you can still solve some good reference books. Any good decent reference book you can choose. You can start practicing it. And afterwards, then you can solve previous year's questions. So whenever you solve previous year's questions, I would recommend begin with mains PYQs and then move to advanced PYQs. In mains also begin with 2020 onwards, but for advanced you can solve 2000 onwards. So 2020 to 2026. For advanced also 2000 onward to 2026. That should be the flow. Whatever category you belong to, you follow as per that. When will be the next class? मैं पढ़ा क्या रहा हूँ? Albin Kuruvilla. I have been teaching relations and functions for class 11th. IDJ. Backlog we were trying to cover with this one shot, but we totally believe that you need more practice. This is mainly a coverage of all the concepts in a quick manner. The next class will be very soon. You'll be notified. Although stay tuned with our WhatsApp channel as well. There will keep posted about the upcoming class. I'll definitely personally put a next reminder. Sure. Any other queries or confusions if you have, please ask. Otherwise, we'll call it a day. Everyone, shall we? So I hope it was a great session. You must have learnt a lot, at least few things. So let's call it a day. Any other queries or concerns? Keep us posted. We'll definitely resolve them. Thank you so much. Thank you so much. Thank you really, really so much. You have been a great audience. And keep preparing, keep studying, and keep yourself energized, active, and participating like this. Thank you so much. Good night, everyone. Good night.